morning, everyone. I'm Umesh Karala, Chief Media, Ministry of Work.
Namaste and good morning. This is Vishnu Hari Devkota, working in the Ministry of Agriculture and Livestock Development in Nepal. Thank you.
Hi, everyone. I'm Ms. Hasula Vikramasinghe, representing the Ministry of Environment, Climate Change Secretariat. I'm also assisting in the preparation of the nationally determined contributions, implementation, and monitoring plan, as well as the National Adaptation Plan Readiness Support Project. Thank you.
Good morning. Namaste. I am Parshuram Paudal from Nepal, Ministry of Forest and Environment.
Good morning and namaste to everyone. It's me, Imal Gautam, from Ministry of Finance, Nepal. And currently I have been looking after Forest and Environment Desk. Thank you.
Namaste and very good morning to all. It's me, Robin Kumar Galan, working as an Assistant Soil Conservation Officer in Ministry of Forest and Environment, Nepal. Thank you.
Namaste, good morning. I'm Purnasundarlal Rajbandari. I'm ADPC Nepal Country Project Lead. Thank you.
Well, good morning. My name is Colin Fernandez. I work for the Red Cross based in Bangkok, Thailand. My work is to support the national societies in the region of Asia Pacific on resilience. Thank you.
Good morning. Namaste, everyone. I'm Rajendra Sharma, working in the National Disaster Risk Reduction and Management Authority, NDRRMA, Nepal, as Undersecretary Hydrologist. Thank you.
Hi, everyone. I'm Udit Yasinga from Sri Lanka, former Secretary to the Minister of Agriculture. And by profession, I'm a Vice Chancellor of the Minister of Sri Lanka and Professor in Agriculture Economics and Policy, and representing the Sri Lankan government together with my colleague.
Good morning, I'm Naho Shibuya from the World Bank.
Good morning, this is Hemang Karelia from the World Bank.
Good morning, Namaste. I'm Krishna Bahadur Patwal, Senior Divisional Engineer in Deployment of Local Infrastructure, Nepal. I am Sector Focal Person of Transport.
Very good morning and Namaste to all. This is Kapil Gyamali from Water and Energy Commission Secretary of Nepal as a Senior Hydrologist. I'm also focal point of this in water sector of ADPC project. Thank you very much.
Good morning, everyone. I'm Sanjeev Baral. I'm Deputy Director General from Department of Water Resource and Irrigation, Nepal. Thank you.
Assalamu alaikum. This is Mr. Hassan Shahriar, Senior Scientific Officer, Water Resource Planning Organization under Ministry of Water Resources, Bangladesh. My background is hydrogeology.
Good morning, everyone. I am Pasupati Chaudhary. I'm working as a resilient agriculture specialist and also sector lead for agriculture sector for Care for Southeast Asia project from ADPC.
Good morning, Borida. I'm Russell Isaac, and I'm Communications and Knowledge Management Consultant for ADPC.
Good morning. My name is Srinivasan. I work at RIMES as a climate application scientist.
Good morning. I'm Subbayya. I'm Director of RIMES.
Good morning, everyone. This is Shakil Ahmed, Country Coordinator, Pakistan for CARE project with RIMES. Thank you.
Good morning and Assalamu alaikum. My name is Juma Khan. I am working in agriculture research as Director of Plant Production in Bhutan and also a focal person for CARE in Bhutan. Thank you.
Good morning, everyone. Abdul Razak Khilji, Director General Water Resources Directorate, Irrigation Department, Balochistan, Pakistan, focal person for water sector.
Good morning, everyone. I'm Anshul Agarwal. I'm leading hydrology team at RANKS here in Thailand.
Good morning. This is Subesh Takal, RIMES Country Coordinator, Nepal. Thank you.
Morning, everyone. I'm Salim Sakir. I work as mobile developer at RIMES. Thank you.
Assalamu alaikum. Good morning. I'm Mohammad Rafiq Islam from World Bank.
Good morning, Shajib Hassan, working as an IT expert here in Bangladesh. Thank you.
Good morning, everyone. I'm Najim Hassan Shaun, working as a DSS lead in RIMES. Thank you.
Good morning, everyone. This is Raihan. I'm working as the country coordinator for care project in Bangladesh.
Good morning, everyone. My name is Sanjay Shrestha. I'm working at RIMES under the development of RDAS portal.
Good morning, everyone. My name is J.N.A. Nayug, and I work as M&E Specialist for Care Component 1 from RIMES.
Good morning, everyone. I'm Ruby, working as Project Director for Care Component 1, implemented by RIMES.
Good morning, everyone. My name is Irfan. I'm Director ADPC in Bangkok.
Good morning, everyone. My name is Nurul Alam. I'm a transport lead from ADPC Bangkok.
Good morning, everyone. I'm Manibinder Gurung. I'm working as a software developer for RIMES.
Good morning, everyone. This is Israel. I am the Senior Project Manager for ADPC and a Climate Policy Planning Specialist for CARE.
Good morning, everyone. This is Andre van Straten. I'm Knowledge Management Officer with ADPC.
Good morning to all. This is Homolata. I'm in the knowledge management with ADPC.
Hi, a very good morning. I'm Navraj. I'm the climate finance specialist at ADPC Bangkok. Thank you.
Those who are joining us over by Zoom, we are very happy to have you with us today. I'd like to introduce myself. My name is Nika De Guzman. I am Information Communication and Knowledge Management Specialist for Care Component 1 in the RIMES. It is my privilege and pleasure to welcome you all on behalf of RIMES today for Day 2 of Care for South Asia Regional Workshop. For today's workshop on RDAS and DSS's user development, we will be sharing the new features of the Regional Resilience Data and Analytics Services, or RDAS, and select decision support systems and DSSs being developed by RIMES for enhancing climate resilience in the South Asian region. Just for the benefit of everyone, we'll be sharing here the agenda and go through it quickly so you know what to expect from today's event. So as you can see, the workshop is divided into two segments. This morning we'll be focusing on and in the afternoon we'll be highlighting the DSSs in Bangladesh. We are very fortunate to have with us today in person and virtually a distinguished group of climate and planning experts and leaders from the region to share with us their experience in the development and application of the RDAS and DSSs in the management of climate risks and opportunities. We will also be having a panel discussion and breakout rooms later to give everyone a chance to deep dive into the systems. So we are inviting strongly encouraging everyone, including those over Zoom, to please feel free to share any comments or questions that you may have regarding the systems during these sessions. Now, without further ado, please allow me to introduce our first speaker who will be presenting about the RDAS development process. He's the team lead for RDAS and DSS development and head of IT at RAMS. Ladies and gentlemen, please welcome Dr. Ikesh.
Okay, very good morning, everyone. Myself Ikesh Das, and what I'll be doing is discussing. So I'll just take you through very briefly on what we're actually doing in terms of
Excuse me, Ikesh. We can't hear you at all.
For the benefit of those who are joining us just today, so I'll also discuss about a little background on the CARE project itself, and then we'll go into the RDAS process, and which will be followed by a demonstration of the tool itself. So again, I will just start with the RDAS overall care project component one. So as you see, the care project overall design and development process was in a way to bring or promoting evidence-based climate smart decision-making process into the context into various sectors in the region, in the South Asian region. So under this, RIMES is actually tasked to develop two aspects. One, of course, a regional portal or a platform which will provide you access to all the data needs that you have, and also support in terms of different sort of analytics and processes that you can do using these data sets. The second component which RIMES is also doing under this particular project component one is on developing sector-specific decision support system. We have started piloting initially for 3 countries in the South Asian region, focusing on development processes in each country, which include agriculture, water resources, transport, and planning and finance sectors. So yeah, so the concept of RDAS, I will actually start talking. So the concept of the regional resilience data analytics platform actually was envisioned or started back in 2020 when we actually started designing the CARE project with support from the bank team, was to bring out a common data portal which can provide you access to different set of both climate as well as sectoral data sets to support your decision-making process. That we have seen that whenever we start doing something, what we are actually at the we lack is access to the data sets. So in the RDAS development process, we started conceptualizing and bringing out some of these processes so that we will be able to provide increased access to regional climate data, which is of course the CIMIC 6 projection data sets that we will be working with and providing with the information on that. I already mentioned about this. Again, the tool will be focusing on 4 priority sectors, and which will include agriculture services, water resource management, transport, resilient transport, investment processes, and planning in the countries. And in the process, we will be also focusing a lot on in terms of the development, the capacity development. Switch it off, otherwise it will go ahead. Okay, so I'll come out of that as so we'll be working on also in terms of the capacity development of each of this department in terms of using these tools as the tools are going towards the completion of the development phase. What actually we are bringing new in the process of the RDAS development, as we know there are a lot of portals which are already there to provide a lot of data and process. So what we are trying to do is bring out like state-of-the-art technology, AI-enabled climate analytical service platform, which would not just provide you access to the data, but rather will actually support you in terms of making some analysis using these data sets and then coming up with your own set of decision context for different sectors. It also would be working as one of the interfaces that we saw is one of the challenges and one of the gaps that in each country is linking the Met services, the scientific organization, to the user agencies who are actually making use of the climate information. So this tool also would be acting as one of the interfaces between the Met services and the user agencies in the countries. And of course, it will help in terms of making informed decisions, because it will be providing you access to all this range of information in terms of climate data, in terms of sectoral data that you can actually make use of to make decisions. I will actually go in detail, little bit detail into each of these. The other thing is, again, making a repository of all the data sets that is available in the region and bring into a common platform. And then focusing on providing downscale. We are using the best possible data sources, CIMIC 6 or the projection data sets that is available now, which is at 25 kilometer resolution data sets, integrating into the tool for the region. And one of the the key point of this tool also is we're trying to make sure that it is actually scalable and it can be actually accommodating as the data need grows in the region. It can actually accommodate those with various data needs from the countries, from different sectors in the process. Sorry for that. I cannot move it. Yeah. So you can control it. Okay. Thanks. So yeah, just to again highlight some of the things that what RDAS can actually support the whole region. Actually, as such, is one component. Of course, is providing access to all the data. What we are doing here is integrating data sources that are coming in from various organizations which have already developed, are in various stages of access. And we are integrating those data sets into the platform. One of the core aspect of the RDAS system is providing access to the latest AR6 projection scenarios, the SSP scenario data sets that will be integrated under this platform. So we are also providing access to the historical climate data sets for you to understand and analyze the climatological information for a particular location or a particular region in the countries. The data sets that are available will be all open. So we are integrating the data that is completely open and is available otherwise. So it will be not restricting any access as such to any of the countries. So you can actually go in and have access to the data and actually do a number of analytical processes that you want to do using the system also. Yeah, so that is the second pillar under this component where you will not actually only have access to the data sets, because there are a lot of portals which is already providing you access to the data sets. What we are actually doing is how you can customize these data sets or use it to your to meet your requirement in terms of what does this data means, what does this projection scenarios means to us, and how we can actually infer different decisions from these particular data sets. So those are the analytical processes that we are also building through algorithms into the system. And the last component that we have under the RDAS system would be linking it with your adaptation plans. So countries have the national adaptation plans. So what we are actually trying to do is build this bridge of using the climate change projection data and linking it to your adaptation plans in the country, so that you can actually have a seamless information flow in the system. So I'll just, yeah, again, this is the 4 pillars. Of course, it is going to be a huge repository of all the data sets that we have. We already have around 15 or 18 sources of only data sets that is there. We have started collecting data from like FAOs, UNSCAP, and the sources where we are integrating all the sectoral information relating to agriculture, water resources are all also coming. And the second one is providing different analytical needs that probably you will have, and to meet different user requirements. Each user will have a different set of requirement in terms of the analytics, how we want to use the data sets, and that would say dynamic environment will be created under the system, so that you will be able to do your own set of analysis. Of course, we are already looking into the national adaptation plans in each country, which are recently there, and we're integrating into the system as we go along. So, in a sense, if you see at the top, we are saying advanced user. So probably there will be a question: what does it mean, advanced user and end users? So if I just put it in the context, advanced users, the one who to some extent understand the data itself, for example, med services or probably planning commission, where you will have some understanding of the climate data itself or the sectoral data itself. So you can use the data. So you can actually start from the data side and then start doing the analysis. If you do not understand the data itself, what you can actually do, you can start from the end user's perspective, where you can actually ask a question. So probably it could be an adaptation question that you want to ask relating to agriculture. So when you ask the question, actually the system will actually go backward and link into the data sets. So it's a process where you can have both approach, where you can start with the data and do the analysis, or you can start with the question to get an answer from that system. Next one, please. So what RDAS provides you? Data warehouse, we just discussed. We have a comprehensive data catalog that is inbuilt into the system. So it actually provides you everything about the data that is there in the system. For example, like if you have used data from a particular source, we put the details where the data is coming in, the authenticity of the data sets, the quality of the data set, all the information relating to the data set should be provided. So it remains open to everyone. To to follow through the process of linking or integrating the data to the adaptation plan, we have to bring in a lot of machine learning or artificial intelligence based decision context. To a particular decision. So those are some of the aspects that we are working on, and when it comes to how we are doing it, we are actually doing it in the back end in terms of developing a lot of algorithms. And these algorithms, basically, what they are is, as sectoral experts, how climate information is actually linked to a particular, like agricultural production, for example. So that relationship we will use and put it into the system as an algorithm. And then going into the future in the process. And that is where it brings in this user-relevant decision context. So based on your question, based on your data points, you can actually get the corresponding decision context in the system. And this is one of the forum. Coming to the right side of the screen is this is one of the forum where we want to get. This is again a concept that we started with, and it is not perfect. What we want is to get feedback and suggestions from you, and not just only here, but in the process more regularly. You can have access to the system. We'll be discussing in the demonstration probably a component where you can directly provide your suggestions and comments for the system, how to improve it, what sort of data that is more useful, and what more we can add to the system in terms of analytics and services into the platform. So probably after this demonstration, there will be a discussion on, of course, how we can proceed in terms of what are the additional things that we can do in addition to what we already have in the conceptual framework of the RDAS system. Who are the users? I mean, that is one of the critical questions that that normally we will get when we talk about a system which is talking about different dimensions, different aspects, different components. So it is a platform, like I said, it will be open to everybody. But mostly we are targeting government departments, like you're representing different government departments in the countries. So it could be for agriculture, it could be from water resources. You can go. It could be from planning. It could be from the operational departments as well. You can go in and have access to the data sets and use it to your to meet your needs. We are also keeping it open for academics, like research students who are actually using a lot of data sets for the research and application. So we will be able to access the data sets and use it for your analytical research purposes. Development partners, actually we are already integrating a lot of data from the development part, actually, like UNSCAP, FAOs. We are already integrating a lot of open data that is already existing. And so they can also use the system to access some of the climate data and information in the process. And of course, private entities and organizations or non-governmental organizations are also welcome to use the tool. And the platform is open for everybody to come in and suggest. Next slide, please. So I'll not go in detail. I think probably when we will discuss in detail about the decision context, it is just showing. I mentioned about we are talking about decision trees, how the decision is actually made. And this is talking from the user's context, end user's context. So we ask a single question or a simple question to the system. So I'm just putting how it will actually use the different pillars to answer that question. So to answer an agriculture-related question, whether or not we should go for a particular crop or we should use a particular crop or not, what are the different steps that system actually will go through to provide you that answer? So what are the needs in terms of agricultural indicators? To answer a question relating to agriculture, we need agricultural indicators. So what are those agricultural indicators that you have to focus on? To derive those agricultural indicators, what are the parameters, agricultural parameters we need. So we will then go in detail into those parameters in the process. Then we will link it to the climate. So we have access to different set of climate data or climate information. So we'll then link into or develop this relationship of how the climate trend in the past has been in a particular location or a particular area. And then we will link it to all the trends, all the impact related information. For example, it could be yield or production for that particular crop. It could be the land use changes that happened over that particular area. It could be the frequency of the events, floods, droughts that is happening in the area, which are some of the factors that impact in all to that particular question, whether we should go for a particular crop in area or not. And then the analysis part. So there are several analyses. Of course, these are few of the analyses that you can do, but the system will allow you to both do your sectoral trend analysis as well as the climate trend analysis, and then compare them together. And finally, the most critical thing: what are the data that we need to reach to that first question that we have asked? So again, this is only listing probably 10 or 15% of the data sets that we need to answer that first question that we ask. But we need access to all these data sets at different level. If you want to have a like answer this question at a basin level, at a provincial level, or at a district level, so we have to have the data at that level with us. And those data could be agriculture data, it could be climate data, it could be soil information data, it could be your land use information data. So the data has to be there at that level. So that is, we kept it at the end, but it is actually heart of the whole system. And that is why it is called also the data analytics platform. So we use the data to answer this question that we asked for the first. And if you are an advanced user, you can start with the data itself and go backward to get your answer. So yeah. Again, it's again just a conceptual framework. It's the building blocks, how we are targeting the system as a whole. So you have a data section. It could be socioeconomic information. It could be the climate and the processes. And the right side, we start with the decision context. We define the decision criteria for it and link it to the sectoral impacts. And then finally, you will come up with your adaptation solutions. So the data linked to your decision context using the analytical methods that is going in the diagonal, if I say in the slope, and finally coming to the adaptation solutions that we have. Next one, please. So we will have a demonstration of the system. So just to give you what we have in the system, but I just put few screens in terms of what the system has. In terms of you want to see the country profile for now we have for the whole South Asia region. You can see the climate profile of the country. You can see some of the sectoral profile of the country as well. You can have an access to the data catalog, like where we have all sector-wise data catalog is available. Under the data catalog also, we have integrated a lot of this open data which is available in different platforms. Like I think one of the major source is World Bank's the climate change knowledge portal itself. And there is another portal which I think World Bank developed is the SARCAD of the Spatial Agent, which has again access to a lot of data sets. And so rather than again producing a lot of this information, we are just integrating those data sets into RDAS. So again, making it a repository of all data needs that you may have. And then you can use the system to do your own analysis. You can choose different scenarios, different models, different regions, different basins, and see the climate, past climate trends, or also the future climate projection scenarios in the process. Next, please. Yeah, I have already talked about it. I just mentioned few of the sources of data that we have, and mostly coming from the next NASA, which is providing the CMIP6 projection scenarios for until 2020 or 2100, and it is available with both daily and monthly scale, but we are providing it at a decadal scale. We are also putting a lot of this sectoral information in terms of whether it's a road network or it is a land use cover or land use map. So you can always have a look in a regional perspective of these data sets. And of course, Google Earth Engine is one of the major components that we are using as a backend also to present some of this data and the information in the process. Next one. And of course, ECMWF is one of our major partner where we are using both the seasonal and daily scale data sets also that will be integrated in the future in this process. So just highlighting few things like the adaptation questions is it's very small, sorry you cannot see probably, but some of these questions are there. And what we want from you also in the future, not exactly today, but to provide us these questions, what sort of questions that you think would be useful, especially in the decision context that for each of the sectors. So these are few questions that we thought, but as we have the questions, then we will actually go backward and see what are the processes that we just discussed would be needed to meet that or answer that question. So we'll go to the comparative analysis of different models, different data sets using the system in the demonstration process. So I'll go to that. Next one. Yeah, so I'll take a little bit of time to explain this one. As I mentioned in the beginning, what we are doing is we are developing a regional portal, which you see is sitting at the top, which is providing all the data needs of the region, not just only the countries. And then we have a component on the DSS development process in the countries with different sectors. And we are highlighting the different sectors that we are working in the countries. And as we go along, what actually happen is all the data needs for the sectoral DSS will be made by RDAS. So RDAS will be the hub to provide any data need that actually the DSS will have, and any analytical need the DSS will have, and it will be actually linked to the DSS in the process. So the DSS will be, or the national DSS system will be providing you a lot of granular services in terms of like spatial or temporal scale, providing you advisory services that can be used on a regular basis, on a day-to-day basis. But it can be also using climate change projection scenarios that is coming in from the RDAS system to provide you more broader planning context in the process. So you have access to the range of climate information starting from the projection to daily scale product, which then you can use. Decision support system in the countries would be working in the process. Just skip it. Next one. This is just one. Sorry, I think it is even I cannot read it. So it is just giving one example that we had in Bangladesh. Especially how this whole process is linked in terms of the data that is coming in from the system to the decision context in Bangladesh. So we have used ECMWF global model data sets and developed several localized context models. It is for hydrology division FFWC at Bangladesh. How we can use the global meteorological data sets coming in from ECMWF and customize it, use it in the hydrological model and generate water level discharge and flow information that can then guide FFWC in terms of making their decisions in terms of water management and in terms of flood management process in the system. And the data also is used in other sectors, of course, agriculture department, I think livestock department and all, and it's just explaining how it is used in the process by each of the departments. So it is I think 2017 or 18 we started using ECMWF data and processing those data sets. So yeah, it's just explaining like how it is actually in place in Bangladesh. So probably this is my last slide. Sorry, I think it took a little more time, but it is where we are now in the system development, just to provide you a when we have more data coming in, the system will be able to accommodate that data request. And we try to 2023 is our actually target to complete the development process, and then going into the full experimental operation and full operation phase in 2024 and 25. And in the process, what we want, like I said, to have continuous feedback from users, from expert users, from users like you. So we encourage you, please, whenever you have time, visit in between. You can come back and provide your suggestions and comments in the suggestion box that we have in the system. Anything, it could be, it can be also a comment, it can be also a critics that this is not working, that is not working. Should be, but critics in a way that will help us to a full development phase now in the process. So I think I will stop here. I think that's my last slide. So thank you so much. Thanks a lot. So I hope this tool will be useful for you.
Thank you so much, Dr. Ritesh. We can really tell that the RDAS is a powerful tool with a lot to offer. But for the uninitiated, it may be overwhelming, no? Some of our participants may be wondering, how exactly can the RDAS help us? Or what can I use it for as a decision maker or as someone, not really coming from a technical background, but would really like to integrate climate resilience in our decision making processes. Here to answer those questions and to walk us through what the RDAS can offer, may we please welcome Mr. Sanjil Shrestha, data visualization expert at RIMES.
Thank you, Nika, for the introduction, and thanks, Itesh, for the presentation. So as I introduce myself, my name is Sanjil Shrestha. I'm currently working at RIMES for the development of the RDAS portal. So whatever Itesh mentioned so far in his presentations, we are just trying to replicate that in an application. So to begin, before I dive into the system, I just wanted to clarify two things about RDAS. One is RDAS is a system which we created not to reinvent the wheel. We are not trying to build something that is new, that's going to bring something new to the table. But when we started the project, we found that there are numerous projects that has been done by many different organizations in climate context. And they all are good, but they are a little bit distributed. You may not be aware of them. Even people working at climate scenarios and climate experts, when we pair with them, they also mention there are tools that we develop now and then every time. So the first thing that I wanted to address is RDAS is a portal which is trying to curate those data, not to invent those data. Second thing on the RDAS portal is that this is still in the rudimentary state. It's not trying to solve all the problem right now. As it is mentioned, there are questions that we wanted to answer, but we are in the process of development. So you have to take the data with a pinch of salt, and then we can check more on that. So Sorry for the delay, there is some technical issues. I'm sure. I have to change the Zoom. Okay. Maybe you can just follow the link. Okay. Just yeah, those who wanted to visit, they can actually visit at rdas.rhymes.int. So maybe you can open that link on your computer as well, and then you can follow. So sorry for the delay. So to begin the RDAS portal, we started about something familiar, like something that people are much aware of. So when you visit the system, it looks like a website. It more divided things by profiles. So we divide things like country profile, sector profile, disaster profile. So for example, if we begin with Bangladesh, then you can see that the first data that you're seeing here at the top is collected from the World Bank. So the World Bank has the data for the average monthly temperature and rainfall in Bangladesh, and that information is available here. Next, there is also a World Bank database that is available from the observed average annual mean temperature, which is also available. Then followed by anomalies and the projected anomalies. Then we try to curate some more data from the FAO side, like rice padding, maize, and even disaster. Like so in Bangladesh, maybe the storm is one of the more disastrous event among the others. So we can compare between what are the disasters per country in Bangladesh. We also try to group it by the decade about the number of events. And you can see that the number of events are eventually more or less growing every year. They also have, sorry, they also have events and in here. And the same profile is available for all the other countries. Now, in order to separate out, draw a line here, that we are not trying to go in detail of the countries. For that one, you may have to visit the DSS section, which is also followed in the afternoon session this time. So they will probably go into the detail of each of the countries in detail, like the transportation sectors, the agriculture sectors. RDAS is trying to see the overview of them. As a policymakers, as a decision makers, you wanted to see a multidimensional 360-degree view among all the sectors, not just a sector. So in order to do that one, the portal is designed along that one. So for Nepal also, there is the similar kind of information that is distributed. Now, the question is, what do I do with this distribution? Is there a relationship I can find between this distribution? So in order to solve that one, we thought about making it some kind of tool that you can readily use. And we came up with the solution of, like, what if these data are treated like a shopping baskets, right? What if the whole data set that we have is like a department store, and then you pick what you wanted to see and then put them together and make your own report. So here, let me give you an example. So for example, in Bangladesh, if I wanted to see if the rainfall, so I pick up a rainfall, there is a rainfall average temperature session that is going from 1900 to 2021, including the projection one. And I put into the crop production from FAO. So I bring in these two together. And once these two are together, at the top right side, you see a small icon that says 2 in the basket. And then you have your report together. So you can compare these data together side to side, right? The people who are more working in this area, they may know a little bit more better than me on this topic. So they can compare whether the climate change or the forecasted climate change has any impact on the crop generations. Similarly, we also group the data at the agriculture level, right? So for example, in the agriculture sector, the rainfalls are happening, like we can observe manually that there are rainfall are shifting every year. But is there any implication of that one on the crop production? So for example, there is a historical data that we know, which is there by every month, and the average rainfall that is available by every month. So what if I put that into the context, as well as I want to see how my crops will grow on that seasons, right? So I will put that context, and when I go into the system at the base table, then I can see the rainfalls are mostly in June, July for Nepal, And then for the crop productions, you can, if you are an agriculture expert, you know when to seed the crop. So you can play around with the tool to decide which month you begin the crops seeding, right? So it may be it was in the past June, but this year or the coming year, it may have shifted. So you can play around with the tools to understand if that is going to help you. And this is all putting into the context of what you are interested in the data, not what we provide. The data is already there. We just curate them into small things. You pick your basket, you put in your data in yours, and then you can make your own report. Now, once you're done with this one, the main thing is that most of the system will ask you to log in and then save your logins. We try to make it a public site. As Hitesh was pointing out, all the data that we have in the system are public data. We are not generating the data so far. So if these data are public and the data are all available, then we don't need exactly a login system for this one. So what you can do is you can just copy the link that you have created and you can share this link with anyone else. The session that you created here will remain in your computer as long as your computer is open. It will close out once you are done. Once you close out the browser or start a new browser, then your session is deleted. But the URL will remain the same, meaning that if you share this with anybody else, they will see exactly the same sequence that you have added, right? So that we call it the data bin, and I think this might be useful for many to make their own reports out of the data that we have already have. So the next one is we created much of those profiles. Like as I mentioned, we created profile by country, we created profile by sectors. There you may see some of them empty, but that means we are still working on it. We are making and adding more data towards it. And there is also a data that we collected from the disaster side. And you can see that there are data that are coming from World Bank. There are data that are coming from SCAP as well. In SCAP, they have this beautiful tool where they are correlating the population with the climate scenarios. And then this 3D, two-dimensional matrix will show how much climate changes is going to impact on which population densities, right? So if you see a darker color, that means probably the density is higher, and then the climate is going to impact more on that density. So all of these, again, when they are useful, they can always put in your basket and then make your own report. The next part on this one is data catalog. So the data that I showed you are just a grouping of the data by countries and sectors. But in the backend context, in order to get there, we also curate the data from different sources. So our team of data experts has collected some of the data on a backend side, and then they just put it in one system. So for here, we just group them that system into different platform. For example, we have now this one expands the data even more. We are even looking at some of the data that are deepest down in the web, like they are very difficult to find, and then they are also might be useful, right? So we have global cropland data that is available here. We also have land cover data that is available there. We have crop changes. We have forest height change, forest cover, and the list goes on. I mean, there are numerous kind of data, as I mentioned at the beginning, that you can play around with. The only thing is we need to find them in a way, in a single point of stop, right? So rather than Googling around the entire web, you can just find them in here. We also build a search on top of this one so that you can find some of those data directly here. For example, in Nepal, we were looking at the data for the roads network, and we do have the entire network data for Nepal for the road. Now, the next context on this one is how do you, like if there is a data catalog which has a bunch of data, then how do I use it with the climate data? For climate data, we have created, so this is the part where we created the data. For climate data, we ran through different models for 8 different countries, and then different basins. For each of these basins, our backend developers and everyone has contributed to generate this data. And then once the data are generated, they are now available as an API, right? So all these APIs can be used in different contexts by different people and many different places. So these data are then converted into something that we can process. Like, for example, in this scenario, we were looking at the data as like the data for Southeast Asia is processed. You can see only the Southeast Asia is covered. So RIMES are the data for climate. We have climate mean projections, and then climatology, the mean temperature, maximum temperature, precipitation, etc. And for each of these models that has been computed. Now, the next thing is to compare them. So if I am interested in looking at the climate data, and I am interested in to see the impact of that climate data on agriculture, let's say for land coverage, maybe in 2020, if I move the scale back to 2020, somewhere closer to 2020, then you can basically see the differences, or try to compare the differences between the agriculture sector and the climate sector neck to neck each other, and then try to compare if there is any implications of change of temperature on the change of global land coverage. Now, the land coverage data is now the challenges that we face on this one is you're not always able to compare apple and apple, right? Here, we are trying to compare a data that is 10 years apart on the right-hand side with the data that we have maybe every day. So we'll have to come up with a solution that has to be somewhere closer. So that one, I think, is in the progress of how we collect the data and how we process the data. For example, the one on the left-hand side for NESM model, we could only find the historical data up to 2014. After 2014, there are scenario data, SSP2 and SSP5, but it is not treated as historical anymore, right? So they will have to be compared in a way with a little bit of background knowledge on this one, but the tool does provide a solution to be able to compare those items next to each other. Next, we also try to put them together in kind of story so that you can, like I mentioned, at the same level as the data bin, you can also put them together with the historical data, the past data, the crop data, and then kind of find a solution. So for example, we highlighted this one case study from for the food price. So in the given SSP scenario with a baseline and SSP, different SSP, what will be the cost of food price in the future? And if that is the cost price that's going to affect, what should be the change in dietary that people may have to do? Maybe people may have to eat less meat to save the agriculture, or they can change their food eating habits. So some of those solutions can come as a result. We also try to work with the agriculture, like for now we have worked with the agriculture expert who try to correlate the indicators that you find in agriculture, like type of crops, crop phenomenon, the crop duration, soils, with the climate indicators. So we have climate variables, we have crop agriculture variables. Our expert tried to correlate them. For example, in this case, they correlated that the type of crops is dependent on these many climate indicators. But if you choose crop phenomenon, then your indicators may be different. And as Itesh mentioned, there are a bunch of questions that is available there. We have curated some of those questions here, and then we keep adding more and more. But for each of the questions, there will be a set of data that is needed. And for each of the data, we'll come up with a solution. So the road forward for RDAS is to be able to answer these questions with the data we have by putting it all together using the tools that we created. And lastly, just to demonstrate what we can do with the tools, I try to create a case study for recent events. Like, for example, this is an event in Pakistan, which happened, the Pakistan flood that happened from starting of June to end of September. So here, the rainfall data were collected, and then they were just placed on this small timeline, which will show the distribution of rainfall. To find the severity, like back in the news, they always mention about what happened. So those informations are available in the news. But in order to find the severity of the data, here what I've done is like the dark blue dots that you're looking at is the maximum above the average rainfall. So in Pakistan, the average rainfall is around June, July is 250. So every blue dot that you are seeing there is above that average. And you can see that there are a lot of blue dots in here, especially in the midpoints. And that means the rainfalls were extremely high during that period, right? The blinking dots that you are seeing on the 7 different provinces are the size of the average values of that province's rainfall. So as you can see, the bigger the dots, the bigger the rainfalls are, though it is a little bit higher on the southern side, but you can also expect that the rainfall were higher on the northern side as well, right? So they are then compared with the forecast data, meaning that what we see, what we have seen in the real world, can it be predicted? Is it possible to predict that? And based on the forecast systems, it does seem like it is somehow able to predict that. Like you can, as I move around, you can see much of the cases, the left-hand side and the right-hand side, they do match. The blue dots or the color of the blue, intensity of the blue are a little bit closer. Now, again here, as we are comparing the data, the left-hand side data, we have the granular data, so the pixels are smaller. The right-hand side data, it is computed data, the pixels are a little bit bigger, but they are still comparable, right? So yeah, and we have 1-day forecast, we have 2-day forecast, and we have 3-day forecast. And all of these forecasts, more or less, gives you the same kind of result. We also put down in context of how the rainfall works. So the small chart that you're looking at the bottom is actually showing you a summary of the rainfalls for the entire 3 months. The darker color means it's actually heavier rainfall. The lighter color means there is lighter rainfall. So the provinces that are listed on the top, I think they are mostly from the north. So there was a heavy rainfall in the north in the beginning, followed by the heavy rainfall in the south at the Sindh province. And some of the southern rainfalls are much more denser and higher than the northern rainfalls. So with this small analytical graphs, you can just analyze that the rainfall was quite severe in terms of how it was, what it happened. A similar case we also try to do for the drought back in 2003 to see a correlation. In this case, we are looking at the data that is like the SPI index. The SPI index went pretty low at 2003. And because of that, the crops productions were also kind of affected during the same period of time. The river inflow were also affected in the same period of time. And the same rice productions were also kind of a drop in the same period of time. Now, again, this is one-dimensional comparison. So you cannot just say, just because of flood, all the rice were gone. That is not true. That may not be true, because there are other points of time that also has a similar drop, but it does have an effect on those particular duration, which points out that there is some effect of climate on the agriculture and different other sectors. And finally, we have our DSS system as we have in the schedule. The following session will be more followed by the DSS. The DSS will have more detailed information. But just to highlight one information, like how we integrated the DSS system with ours. For example, in the afternoon, you will probably see a DSS system for livestock. And we try to get those livestock directly into the data as well. So here, this one is focusing on the foot and mouth disease clusters that are created around Bangladesh. Again, as this data is available by the DSS system, we try to integrate them. And this one can again be put into our basket, and we can compare whether the foot and mouth disease is related to our intensity of heat, temperature, or rainfall. Right? And finally, just to, I think I was given an indicator that we are ending. Just to end the session, I would like to say that we also added a small feedback system. So if you have any more feedbacks, we would like you to add those feedback. Again, you don't need any logins for this one. You can just add in your feedback. You can add in your information. And as a community, we can vote on that information. Like there may be some ideas that are more important than others, and they can be rolled out much quicker than others. So in this, we also have a change map, a roadmap that will create it, and then those ideas will simply get implemented, which means when the development of RDAS is going on, you all can be a part of those events, and be a contributor on that one. So as your events, as your questions are being asked, you can see a progress of those questions alongside with how we are developing. And then you can give us more feedback afterwards as well. So we believe that RDAS will bring something in your working principles. We believe it will bring more integrate all the tasks that you're doing, And we believe that we can make the tools a little more better next time and further coming days as well. So with that, thank you very much. Thank you for listening.
Thank you, Sanjil, for that very comprehensive presentation on the RDAS capacities. Are there any? Oh, okay. So I believe everyone's feeling a little overwhelmed already by all these technical discussions. Before we move on to the next part of the program, we'll be entering a 15-minute break. So we'll reconvene. Yes. Okay. It seems there's a burning question from one of our friends. Pastilla from Nepal.
It is not a question actually. You can see it is a request or a suggestion, not a question. First, I want to thank you for presentation, for both presentation. I'm so happy to have the system, information system, so that will help us not only doesn't need account or login system. Besides that, I want to suggest you to make it in national language also. Like for Nepal, let's make one topic for Nepal. In Urdu or in Bangladesh in Bangla. So even people can. It is in developing phase, so if you act that like that in this system, then you can make a better platform for knowledge sharing. Thank you.
Thank you, ma'am. The automated system is not always the exact gist of the problem. So when we are looking at the data, RDAS is mostly focused on the data, and the data are in numbers in most of the cases. But in order to get that data into a report kind of thing, as I showed you in the report page, we are just now curating the data as a block of charts. But what we believe that those block of charts can be converted into a narration. And for that one, there are system and AI systems that are available, which can literate us some paragraphs. So in coming days, I think we were thinking about putting a translation of those information so that the report looks like report, not a series of charts. So in this sequence, we will also consider including the national languages from as long as we can find resources for translation. Thank you, ma'am.
Both of the presentation were very good, and it is like we keep on learning the things. My you can say that observations or questions whatsoever. How do you decide that this data is better than the other one? Like, what is the quality parameters of the data? If there are certain reports, for example, in Pakistan, we have got the information of the GIG reports, which is also for the World Bank. We have the IPPC reports. Is there any priority characterization that this report, if there is a conflict of the two reports, maybe it can be in the future or in the present scenario, and there will be an issue, then which one that system will follow, so that it will be user friendly and user does understand. My second one question is, various future predictions were given, like you were given you were showing the country profile regarding the sowing of the crops like this. But for us to understand that there are three types of scenarios. One is business as usual, extreme scenarios, normal scenarios, RP1, RP. There are various scenarios. But when you put the one data, it does not depict that it is a business as usual or it is extreme one. What kind of output that the system will show at that time for the future projection? Because you are giving the information for the one parameter, and you are putting that one parameter into the whole scenario. Is it going to work for us? That is a bit confusing for me. Thanks.
I'll just write.
First, you respond.
To answer the two questions, one of course on the quality of the data and the sources of the information. And as you see, so what we have done is we are trying to get the data from the best sources that is available, and there, like whether we talk about ECMWF or the World Bank portal itself or any other sources. Those are actually tested and verified sources. But on top of that, what we're actually giving you in the system is access that where advanced user can actually do your own analysis to see which forecast data is actually working well in the region or not. So that, as a user in Pakistan from the Planning Commission, you know which data is used. You can also suggest different data sources which you have already tested. You think that, okay, this data source is good for Pakistan, why not include it? So that can be included. Because it is an open platform, we can keep adding new data sources. And that is the suggestion that we are actually requesting everyone to make. PMD has a lot of information or data sets that can be also added, which are of course open in the forum. So far, we have put all the data sets. The analysis and all will actually be done impromptu in the system. The system will actually tell you which forecast is good, which forecast is not bad or not good in the process. Now, coming to the second question in terms of, we just showed one scenario. We just said, okay, this is what is going to happen. But the system provides you the flexibility. You can actually choose, okay, this is one scenario that I have chosen, so which is showing me that, like we have now, if you talk about the SSP 4 scenarios or 5 scenarios that we have a best case scenario, we have the worst case scenario. So you can actually choose using the system, okay, what will happen if I choose the best case SSP1, or what will happen if I choose the SSP5 scenario. So that is up to you, the decision maker, to choose and see how it is going to impact, and then use that for decision making. So the system is actually not directing you that this is going to happen and you have to use this. No, it is giving you all the options, all the possibilities that can happen. So you have the flexibility to choose which data you want to see. In fact, in terms of the comparison also, sir, you can actually do a comparison between, let's say, you mentioned about GIC data or ECMWF data to see which one is working well. So you can have 3 scenarios. Okay, this is our observation data for example, if you talk about the Pakistan flood, we can put, this is the actual scenario. This is the ECMWF forecast. This is GIZ forecast. This is GFS forecast. This is Pakistan Met Department forecast. So we can compare and see under one platform which forecast actually was the best, and then the reliability on that source increases. So just to summarize, the system gives you the flexibility to choose and compare the data information that you want to do in the process. Yeah.
No, just we have only one room for one question, and just to quickly add, as I mentioned there, the whole portal is designed to be a department store. You can have mama, you can have ramen, you choose what you want, and then you can make your own menu. Sorry, I was just mentioned that we can have only one question right now, but after that we'll have a panel discussion, and we'll follow up with the panel discussion question along with that one. So one question for now. Yes, ma'am.
Thank you, Sanjilji and Idrisji, for a very informative presentation, and indeed DSS tool looks very promising.
I'm just wondering and curious to know if you have a plan to kind of disaggregate data by different social variables that would contribute to gender analytics. And I'm saying that because under CARE project in ADPC, under cross-cutting theme, gender inclusion, what we are doing is basically doing the analytical work where we do the policy analysis. And one of the gaps or challenge, if you like, I mean, coming up from all three project countries is basically lack of, data sets on women's and marginalized groups in relation to vulnerability and race to different hazards. So I'm just wondering, and since you are saying that this DSS system would help to policymakers and decision makers to link in development of adaptation plan. And when you talk about adaptation plan, I think so disaggregating data by social variables, different social, either men and women, ethnic minority or, disability is very, very critical and important. So just wondering if you have that in plan. And that would also basically leverage the work that, we are doing in ADPC of the policy analysis to maximize the impact and output. Thank you.
Yes, thank you, ma'am. I would like to add before Hitesh for that one. Right now, currently, as of now, we don't have a gender data on our portal yet, but that doesn't mean we should not have. I believe that we should have. For the RDAS, again, to emphasize, RDAS is not a DSS system. For the DSS system, there will be a follow-up session after in the afternoon. The DSS system is mostly focused on the day-to-day activities within the country. RDAS is trying to compare those activities in a higher form. And in doing that, I think comparing it with more data is much more valuable. We can include as diverse data as we can. The issue that we are facing is we have resources. We have people who are working in sectors and they are contributing and helping us find those data sets. But if we have some of those resources or some help from the community side, which will point us to the right direction of where we can have what are the topics that you are interested in, and then we can try to find those data from our side as well. As I mentioned, RDAS portal is not designed to generate those data, but if the data is existing there, we can definitely put the data in context of the climate. Because what we believe is that climate change and the comparison with the scenario is not apple to apple. You cannot do it one at a time in line item. You have to look a 360-degree or any number of data that is available. Maybe one or the other is contributing or being affected by those changes in one way or another.
Thanks very much for that question. I think the idea of RDAS is to pull together the data that is available so that when and if needed for whatever you are doing, climate related, you have available data, you have available analytics for whatever analysis that you can have, agriculture, water resources, labor force, livestock, etc. Such that even when you are doing development planning, whatever kind of policies you are doing, you can access RDAS, all kinds of analysis, then that can aid your development planning for whatever sector. The important here is that we have quality data contributed by everyone. You participate in discussions that we will be having later on, because the idea again for RDAS and all the decision support systems that will be shown this afternoon is to evolve it per your requirements. Because ultimately, the value of the system is to make it available for use. If we don't meet that requirement, what is the value of the system? So we drive that development process. We are in the middle of development. We are targeting to put it forward as soon as possible. Actually, RDAS will be made available now for access so that you can experiment on the use of the data and then let us know what else you need, because again, we are on the process of development. I know there are still questions pending on the floor, but we have to break, sorry, for, if possible for everyone, only 10 minutes. And then we can come back because we have a panel discussion following. Our panel discussants are waiting online. But after the panel discussion, we will entertain all questions related to RDAS. And the panel discussion will also feed into this RDAS discussion. Please, so if I can request a shortened break, instead of 15 minutes, if we can do 10, and then we can come back and, sorry, continue the discussion. Thank you so much.
Hello, everyone. We're about to resume the program. So if everyone could please get back to their seats so we could start with the panel discussion.
Okay, can we request everyone to come back to the hall? Requesting everyone to come back to the hall. Sorry for disturbing everyone in trying to explore the systems, but you will have, I think, throughout the day to explore the systems. So I just need, I think, a little bit over 1 hour this morning. Okay, again, we're trying to call everyone in so we can start with a panel discussion. I know there is some level of excitement to exploring the systems, but we can proceed on that after we complete the panel discussions.
That's why. All right, welcome back, everyone. We'll be starting with the panel discussion now. We are very fortunate to have with us today for today's panel on site and virtually many experts in climate resilience from various sectors. So allow me to first introduce our panel members. First, we have Dr. Nagara Chahrao Harshadi, Global Lead for Disruptive Technology and the Sustainable Development Practice Group of the World Bank. He'll be joining us virtually. We also have with us Mr. Muhammad Ayub Sumro, Additional Secretary, Technical and Irrigation Department. Mr. Sumro, may we please ask you to join us on stage for the panel discussion, sir. We also have with us Mr. Anil Pokhrel, Chief Executive, National Disaster Risk Reduction and Management Authority in Nepal. And we also have Mr. Colin Fernandez, Preparedness Technical Lead for the American Red Cross. Please join us on stage, sir. And last but not the least, we have Dr. Michael Ernst, USAID and Office of U.S. Foreign Disaster Assistance Regional Advisor for South Asia, joining us over via Zoom. And then to facilitate the discussions, we have Ms. Ruby Rose Policarpio, Project Director, Care Component 1 on the lines.
Yeah, thank you very much. So this will also build on, sir, you want to sit here as well? Let's make this a very friendly discussion. Again, we are encouraging very informal discussions because again, feedback is really part of what we want from you. And to initiate this is to basically bring forward discussions from all sectors, from all possible use of the RDAS and other DSSS. So we are fortunate now to be joined by Harsh from World Bank. He is traveling now, he's in Africa, but he has taken time to join us. He will show us a presentation. The questions will, basically he will talk about cutting edge technologies for systems like RDAS and DSSS. So we will first hear from him, to be followed by experiences from the countries as well as from our regional stakeholders on challenges, experiences on dealing with climate-related risks. So Harsh, if you're ready with your presentation, then I give you the floor. Harsh will be joining us virtually. The floor is yours.
Sure. Thank you very much. I hope you can hear me okay. I'm joining you from Kano in northern Nigeria. And
Harsh, sorry, we can't hear you.
Can you hear me? 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 I think online they can hear me, but I think in the room you need to. Can you hear me now?
I think we are having some audio issues.
Mr. Anil, you can hear me okay?
Or muted?
Harsh, we can hear you loud and clear.
Good. So I think it's in the room, I think.
Can we check? Can we check with Harsh?
Yeah, I mean,
I think he's not hearing. I'm not sure. Harsh, are you hearing us?
Yeah,
we hear you loud and clear.
Okay.
Yeah, we can hear you.
Having...
And, I think you need to connect up the audio.
Okay, please bear with us.
I'll keep saying something so that you'll know if you're connected. So, hello. Yeah, I think online they can hear me, but I think in the room they need to be connected to the audio from the Zoom.
Okay, give us a few minutes to
Sure.
solve the issue.
Thank you, Mr. Syed, Saroj, Michael.
Okay. As we're waiting for the audio to be fixed, we are looking at our physical participants here. So basically the topic of the discussion will be on climate information needs for robust planning and decision making in South Asian region. So the panelists will give you their experiences, recent experiences on climate related issues, how they managed their these risks, and what are their information requirements going forward, how we can respond to these information requirements via RDAS or DSS that will be discussed this afternoon. So I will give the floor first to Mr. Ayub, sir. Yes.
Thank you very much. To give you a brief account of the flood disaster that happened in July and August 2022 in Pakistan, especially in Sindh and Balochistan and the southern part of Punjab. These were the early rainfalls that were predicted by Met department earlier, and they told that there will be early monsoon and there will be heavy rainfall as compared to previous years, and that happened true. In July and August, first there were very, very heavy rainfall in Balochistan. Afterwards, the all process continued in Sindh and Punjab, and the Balochistan, the hill torrents that rushed to the Sindh northwestern part, the district of Khairpur, Nathan Shah, Kambar, Shadat Kot, and Dadu and Jamshoro. These are the right side districts of Sindh province. So the water from Balochistan hill torrents came in Sindh, and it ran all along the flood protection band that stops the hill torrent water from entering in the agricultural lands of Sindh. So ultimately, this water was a very high quantum, not seen before. It was very, very high quantum. And simultaneously, there were rainfalls in Sindh and Balochistan too. So accompanied these rainfalls and these hill torrents from Balochistan, there occurred some breaches in the FP1, and also the system that conveyed the water right side of flood water to the Indus River, all this system busted up because these were, if you compared any normal year, June, July, August, these were five times higher rainfalls. For example, if there are rainfalls of 100 millimeter, and 2022 it was more than 500 millimeters in these 2 months. So the system was not even capable to handle or hold it. Everywhere there were breaches and there were floods. Khairpur, Nathan Shah, where even Dadu was in danger. So ultimately, this Mancha Lake was about to burst, but then there were some intentional cuts that were provided to Mancha Lake. Unfortunately, River Indus was also in the floods, almost 6,000. There was no disposal for that. But finally, River Indus subsided, and then so 2 bridges were provided to 7 Larkana Band, and then some pressure was released from the right side. This water is being evacuated. The water that was above the roads or the infrastructure, smart communication infrastructure, that has been drained, but the water that is now in the pockets, that's standing there, and it's very difficult to drain it out. And it will ultimately, I think, will evaporate and somehow from some places may be drained out. So these are the lesson learned from, I think I should also say, there were also some emergency in southeastern districts of the LBOD region. That was also on in ever high floods recorded in LBOD during 2022. So there were three types of floods in Sindh. First, hill torrent floods in upper right of Sindh province, and these rainfall floods in the lower left of Sindh province, and also floods in the river Indus. So these were the floods. So the irrigation department played its role, provided relief cuts to the Indus, to Mancha Lake, and then evacuated the water. But anyhow, in the meantime, there were some cuts or floods, breaches. They inundated almost 3 districts of Upper Sindh. That's Dadu, Khairpur Nathansha, Kambar Shadatpur, and some part of Jamshoro. And that happened, and now that's being drained out. But as I mentioned, that the water that was above the infrastructure, communication infrastructure, that has been drained out, but the water that is standing in the pockets is really difficult to drain it out. So the lesson learned from the last flood is that our existing infrastructure is not disaster resilient as compared to flood disaster. It's completely not disaster resilient. Even when there's a disaster, when there's outflows or discharges, heavy discharge, it cannot get it out. And when there is a receding of the flood, it's not able to get it out because it is closed in compartments. So complete road work, complete irrigation drainage infrastructure, complete housing. For example, these houses are constructed at a very low level, and they are inundated every time. So there's no change in them. So that there should be some raised elevation, completely failure of government infrastructure, hospitals, schools, and everything. So the lesson learned is that all our infrastructure is not disaster resilience with respect to flood disaster. Thank you very much.
Thank you very much, Mr. Ayub Sumro. Mr. Ayub Sumro is the Additional Secretary, Technical for Sindh Irrigation Department. I know that what this discussion basically is implying is that there are a lot of issues vis-a-vis development planning, not possibly also not only on the short-term perspective, but also on long-term development planning. But I'll go back to the questions later, sir, if that's fine. So you can ask questions later to our panelists. Again, there may be similar views from the rest of our discussants participating online from the countries. As of the moment, I think Harsh is ready. The technical issue has been solved. So Harsh, the floor is yours.
Can you hear me now? Can you hear me okay now? Can you hear me now? Can you hear me?
Harsh, we can hear you online, but
yeah,
we're not really sure.
Yeah, people in the room, I'm not sure if they can hear me.
Let's see. I'm in contact with my colleagues in the room, so let me check. I'll check through WhatsApp. Just, but it seems Ruby, they are not hearing you.
Yeah, I don't think so. Ruby, now anyone? Can you hear me?
Harsh, can you hear me?
Yes. Yeah.
Oh, I can hear you. Please go
ahead. We can hear you. But can you hear me?
Yes, very clear now. Very clear.
Perfect. All right. I think we've got it licked finally. Okay. Greetings from northern Nigeria. It doesn't look like my background, my virtual background that I have here, but it's something which I think is a place which also is dealing with a lot of floods currently. So it's something which a place which could also do with some of the aspects that we've been discussing today. So my name is Harsh, and I am something called a global lead for disruptive technology at the World Bank. And I've been at the bank for about 26 years or so, working on water, environment, climate, and technology issues. And it's a pleasure to join you here today, and also to be working the last few years with RIMES and others as part of this project, where I'm helping Naho and Hemang right now. And as part of this work, just wanted to see where we could go in the future a little bit, in the sense of how we can think about disrupting these data value chains that we have in the system. So in any of these river basins or watersheds, we see usually the hydrology, how much rainfall, how much evapotranspiration, how much stream flow, and so on, and interaction with groundwater. But there's a whole bunch of other things that are happening in these spatial hydrologic boundaries, which are rain-fed agriculture. So we'll have an agriculture department looking at it. And if you have many different uses and aspects, we have many different departments and civil society organizations and others who are closely involved with different aspects of this. So how can you use information as a way to help network a lot of this work together, so that you can get a more holistic picture? And that's part of the challenge of RDAS, regional data and analytics system, is to try and see how to get data not just on the hydrology, but on all of these other aspects as well, which are influenced by the climate. So now, in terms of data, we usually have three responses. Oh, we are in the middle of nowhere, we don't have any data. Or this is unfortunately recent pictures from South Asia, where there's a lot of course, we have a lot of data, but it looks like the only digestion of this data is happening by termites and not people. But the new normal is this, that we have a lot of data, a deluge of data. And how do you drink from this is the big challenge, in the sense of how do you interpret and make sense of all of these with new visualization and analytic and interactive tools. So there's a lot of old ways of thinking which really should be scrapped in terms of data secrecy, or to do retail level desktop modeling and so on. But to have more of these analysis ready cloud services, open basic data services, and wholesale platforms, which can make a big difference in the way a lot of the data is used. As we heard earlier, it's really important that a lot of these systems get used, otherwise they are useless, right? So now, all of us are part of the problem. Every time we say you need to fill a form to get a data, tell me your dad's name, you tell me what, and you get the data in some random format like PDFs and so on, to try and change a lot of these old systems to something which is where you're leveraging, like the RDAS is currently, without passwords, without registration, and so on. Things like open data APIs, or open geospatial consortium standards, and cloud analytics, and so on. And these are the things which are the ways of the future. And it's part of this whole range of new technologies where you're looking at converting data to information, to knowledge, to decision support, right? So that's the data value chain, where you're modernizing all aspects of how data is collected, analyzed, and made accessible. And there's a bunch of other types of technologies also which could play a role in terms of new ways of making data collection cheaper, with maybe 3D printed versions of the housing for sensors, which people are doing now, to drop costs of, let's say, water level monitoring from $5,000 a station to $100 per station. Someone needs to mute, please. Okay. And then also to look at stakeholder data value chains, to be able to connect people up together like we are doing today, but in also virtual circles. So the big challenge is, how do you take this bottom-up data, merge it with top-down data from Earth observation and drones and aerial surveys and so on, and link it with data that's been rescued from the termites and also from different models, so that we can use all of these buzzwords of technology and underlying cloud services, because that is the future, to be able to make sure that this data is used in practice, where it can be accessed through anybody's phone or control room. I think the room needs to mute, please. Okay. And then the what's changed also is a whole new range of data visualization tools, where there's all kinds of new ways in which data can be visualized, 2D, 3D maps, 4D maps, where you're looking at 3D maps changing over time, or you're looking at new ways of interactive data visualization, which you have now. So all of these can be brought to bear to deal with real world problems. And the point is not to start or stop with the data, right? It's to more think about what decisions you're trying to support, and then see, for example, if we, as Mr. Ayub just said in Pakistan, if flood coping is a major issue, then what do we need? We need better early warning, and we need some recommendations for people to know what to do when they get the warning. You need to know, for that, you need to know better weather forecasts, hydrologic forecasts, and inundation forecasts. And for that, you need lots of data, lots of modeling, lots of people management to be able to make sure that this entire ecosystem works in order to support that one decision that's there. There's a whole nother set of things in terms of infrastructure to reduce the hazards and so on, like embankments and others, which also is required more on the planning side. But in terms of real time, these are the kinds of things that would be required. So today, with a lot of the satellite data that we have at our disposal, for example, if you look in Bangladesh and you look at getting access to free data sets, please check out all these websites. I'm going to show you only about 4 or 5. One is from the bank itself. We have something called maps.worldbank.org, which is a new way of making a lot of this data accessible. You can see how the chars have moved just in 3 or 4 years in Bangladesh, which is a major issue there. The other is in terms of now you can, with even more things, and Hitesh, you'll really like this, in maps.worldbank.org, it's now similar to our internal platform where you can say, look, I really want to do analytics now. Slowly go away from just the data to doing analytics, to say at the Kosi, where it joins the Ganga, I want to say at that location, draw me a watershed. So now, and this is public, by the way, these systems. So it'll use one of these public systems to draw a watershed at that location. So something from Esri goes in and draws, and then passes this information on to Google Earth Engine, which is also free, right? So what you can do then is say that now, based on this, I want to see what the elevation looks like in this area, right? So then based on this, or population or rainfall or whatever, so you can go in and get access to a lot of these analytics, and you can make them into links or embeds. So you can put an embed of this in your site. So it'll look like it's your site over here, but the back work will be done both by the bank and Google Earth Engine and Esri and others in the thing, and won't cost anything, right? So a lot of these types of tools that can change transparency, background maps, all that stuff. So, and you can even get histograms of elevations at the end and all that. So in addition, FAO has this great site with amazing analytics, also backed by Google Earth Engine, where, for example, if we look at Nepal and we say we want to look at some rainfall data, let's say chirps, which you have for the whole world. So from 1981 onwards, you have even daily versions of this data, which are really good estimates of rainfall data, right? So if we look at Nepal, not as a country, but as an agglomeration of watersheds at level 6, which what they have, and look at, let's say, the Mahakali Sarda thing on the Mahakali system on the extreme left, you can see both things such as what are the average rainfall in that whole period, or you can see what the annual rainfall has been in that whole period, like if you want to look just at annual numbers, or you can look at monthly or even, in fact, daily versions of the data as well. And a lot of these are all freely available, accessible. So there's no need to reinvent a lot of these wheels. And you can start leveraging a lot of analytics that other people are starting to put together in terms of a lot of these data sets. The CHIRPS dataset comes from the University of California, but it's hosted by Google Earth Engine, and it's being accessed through this FAO site. So there's a lot of people working in concert for these kind of things. What's new also is in terms of places like for applications like irrigation. So let's say we look at UP, which has some 20 million hectares of irrigation, right? So you just draw an area, let's say east of Lucknow, someplace, and then say for that area, compute what's the actual evapotranspiration. So this uses some of the MODIS data to say over the last year, how much has been the actual use. And then you can also do this for the entire period of record and say for the last 20 years, what's been the thing, every 10 days, what's been the use. And a lot of this data can also be downloaded, although nowadays no one should really download anything. Just keep the analytics in the cloud, the data in the cloud, and keep the visualizations local by interacting with these systems that are there. And lastly, also things such as, for example, we just heard from Mr. Ayub on Machar Lake and so on. So let's say upstream of that, if you wanted to see what the forecast was. So we're looking at the European Center for Medium Range Weather Forecast and the Group on Earth Observation Global Water Sustainability Effort. They now have a tool which puts for every place in the world an estimate of what the flows might look like in the next 2 weeks. So I'm going back now to the beginning of September and seeing what was the forecast then, right? And also you can look at historical estimates and be able to visualize these for the last 40 years, and also leverage time series. And a lot of these were supposed to be on their way down when the floods actually happened also because of the sustained rainfall. And look at flow duration curves. If you have your own data, you can make it even much better and so on. So a lot of these tools now exist for every place in the world for free, which you can start leveraging and using their APIs into your system, so that over time, what we looked at in the basin in terms of estimating rainfall, evapotranspiration, soil moisture, stream flow, even to some extent groundwater, although that's still not that good, you can start getting a lot of the water balance information for these areas and start leveraging ways in which you can access these using, say, systems which are touch screens, touch tables. This is our office in Pakistan, for example, where we help set some of this up. This is some of our KIDS team, as we call it, Knowledge Information Data Services team in DC, and so on. And a lot of these have become very inexpensive in terms of the hardware to access a lot of these. And this is a time in which a lot of these systems can be better leveraged. So I suggest that as you go in your agile mode, because you don't want to wait for the end of 5 years to say, look, this is the system that's been developed, you should do what you're doing now, which is to make sure that you do in an agile way, make a system and then get feedback from people so you can keep making it better and better quickly. And also increase the number of people who are aware of these systems. You need to reach out a lot more to universities and other agencies and other kind of state governments and other things too, so that you can get more people to start leveraging this data and start making it part of their work over here. And slowly you'll be, I think, the global good practice in terms of regional climate information systems, where you can leverage everybody's work and make it more and more accessible as you go through. So anyway, I'll stop there and back to you folks, and all the best with your deliberations. So the remaining part of the workshop as well. Back to you, Ruby.
Yeah, thanks very much, Harsh. I know that you are boarding a plane shortly. So any burning question for Harsh as of the time being? Okay, so again, thank you very much, Harsh. And then we will proceed with the rest of the questions for our panelists at the end of the discussions by all our discussants. So at this moment, I will call Mr. Anil Pokhrel, Chief Executive of the National Disaster Risk Reduction Management Authority of Nepal, on the same topic. The floor is yours, Mr. Pokhrel. Sir, I think you're muted.
Thank you. Thank you so much. Thanks first and foremost for including me as one of the panelists for today's such a meaningful event. I'm Anil Pokhrel, and I'm the Chief Executive of Nepal's National Disaster Management Authority. It's been nearly 2.5 years plus ever since we established through an act. What I would like to say is over the last 3 years, particularly these 3 monsoons that we've collectively responded, I'd like to kind of again bear on my experiences as what we've been going through, especially looking at landslides, floods, forest fires, and other associated disasters. What we've been experiencing is especially if we look at last year, what happened was even prior to the onset of the monsoon, actually on the very onset day of the monsoon, we experienced the Melamti debris flow and a disaster of a catastrophic proportions. On the very day, on the same very night, we also were hit hard by in other mountain communities, particularly Manang, Mustang, Gorkha, Bazura, and Achang. That too happening on the very first day of the onset was for all of us taken by surprise. We knew that the forecast, the seasonal forecast would bring us more than average rainfall, but we're not expecting it. We couldn't anticipate it on the very first week or on the very first day of the monsoon onset. Secondly, if you take at last year's case of nearly after the monsoon was declared over, we experienced an extreme rainfall situation, something of a tune of more than 540 millimeters in 2 days' time, similar to what our colleagues from Pakistan described just earlier before. This year too, we experienced a similar situation. Well, we are nearing the declaration of the monsoon, that monsoon is over. We experienced extreme rainfall events, mostly starting from the middle and the west of the country. 4 of our provinces were badly hit, and what we've been gathering right now, our field teams are right now in the Midwest and the Far West districts, where the cabinet has recently declared a disaster emergency in those districts and municipalities. Our field teams are sending us daily reports that tell us of a alarming situation in those areas. Landslides have wiped out communities where they were never experienced before. Communities that have never experienced floods, such as in Tila River Basin, Sinja Valley, serene, very picturesque valley. 2 days video that I posted on Facebook now is completely decimated. Hill slopes are now unfit for habitation. We need to look for places where we could safely resettle these houses. In addition to that, again, if you go back year before last, we experienced unprecedented proportions of forest fires throughout the countries, and mostly in areas, in the high mountain areas, where it really takes larger number of years to grow trees. And more importantly, when the soot from these forest fires goes up and lands into these glaciers, there's an accelerated climate change impact, especially the glacial lakes receding very fast, and the glacial lines receding very fast, glacial lakes forming in those areas in a fast rate. What we've also seen is with these landslides, the forest fires, a combination of these impacts has resulted into a more complex and a cascading event. What we've been experiencing in cases in Melamti and other places, especially in the foothills of the Nepal Himalayas, some of those footage where Harsh was showing on these images, an unprecedented amount of debris flow and aggradation of river systems. Now, these aggradation of river systems have led to change of river courses, wiping out number of bridges, settlements, irrigation structures. And so that's the kind of, again, signature events that we're experiencing, which we were not expecting even until a few years back. So what we've been just coming out, even yesterday, under the chairmanship of our chief secretary, we had gathered in the context of preparing for the upcoming COP27, that these incidents, these signature events we're not experiencing before. Climate change is happening much faster than expected, and we're feeling the brunt of it. Now again, back to the question on, again, what is NDRMA, what is our institution doing on it? Now, if we really look at these couple of incidents, what we see is, in the case of Melamti, we're not able to anticipate it. People were only able to get information on an autonomous way. People were kind of calling each other through cell phones and mobile phones. Our stations were wiped out, and we had no early warning systems in those areas. But having said that, again, following the 2015 earthquake, we're able to do quite a substantial amount of pre-position. A lot of training has gone in there, and then a much better response compared to our previous experiences have happened in places such as in Melamti River Basin. I could rate perhaps A or an A+ in terms of the response that we've been able to do. In terms of early warning system, perhaps we can't even get, we'll get an F mark if we're grading a paper on it. But if you look at, again, this year's monsoon and the last 2 weeks, what we see is we're working jointly with DHM, the Hydromet office, and also with support from RIMES, we've been able to learn in advance that these systems were coming up. We're not expecting initially, but again, when we got alerted, we're able to then send these messages to districts and our district administrative offices, our district disaster management committees, local governments, including our responders, pre-positioning our response materials. So we're able to do much better compared to, say, for instance, what we're not able to do in the case of Melamti. But having said that, again, our response were in this case not perhaps not to the best, such as in Melamti, where we had a much better response capacity following the 2015 earthquake. In the mid and far west regions, is very difficult in terms of connectivity. Our roads were wiped out kilometers after kilometers. Our bridges were wiped out. In such case, we're not able to respond with the same effectiveness that we're able to do in the Melamti Basin. So now how do we go ahead on such a complex, fast changing environment is again start working on collective approaches is how we could bring together the hydromet agencies, the other departments such as Ministry of Forests, the roads, agriculture, and others, including the provincial and local governments, to look at ways as how we could we could bring in new techniques and tools, decision supports to address such complex disasters in our settings. So I'll stop here. And then I'll come back later on subsequent questions. Shall I pass it over to you?
Yeah, thanks very much, Mr. Pokrel. Sir, as you've mentioned, we will get back to you later on questions, if any, from the plenary. I'm also acknowledging 46 online participants. That, of course, includes our discussants. And we may be having questions from them also later. Now I hand over the floor to Mr. Colin Fernandez. Mr. Colin Fernandez is the Preparedness Technical Lead of American Red Cross on his perspectives on similar subject.
Thank you, Ruby. First of all, I'd like to thank RIMES for inviting the Red Cross here. As the moderator of the workshop said, all the data which we were listening to can be overwhelming, and really for me, who is more into the human side of preparedness, working with communities, and I listen to all the data and the websites and the information available, and also being in company of a lot of technical people, it can be overwhelming for me. So I am totally at risk in this workshop. But also it's good to see we need to be bringing these two communities together. It's important. The science community, where it works on data, information, gathering it, is there. And also the humanitarian development community, which works with communities, works with local level planning, subnational planning, and to see how these two groups can marry each other, work together, and make sense of that data. Now, as Ruby said earlier, before we got into the break, the data is there. But the important part is, how do we use that information? How we translate that information for it to be helpful for local level. I'm going to be speaking more on in terms of local level planning, where the Red Cross works across the region. So for the local level planner, for the ground military officer of Sri Lanka, for the barangay captain in the Philippines, how can that person with his or her, that difference experience, be able to use this data, use this information and say, okay, this can be helpful when I am going to do my planning. Now, what I'll talk about is just 2 case studies and the learnings from those case studies. One was, I'm just coming back from the Philippines. I was in Catanduanes, and Philippines has this process of development of the LCCAP, the Local Climate Change Action Plan. Now, this plan is being done at the municipal level. How does the Red Cross, the Philippine Red Cross fits in? The Philippine Red Cross fits in because it brings in the whole human perspective, the human face of the impact of climate change and disasters on communities and what they should be doing about it. Now, the LCCAP, the municipalities and the different departments at the municipality is able to access the information from PAGASA, which is the Met Department of the Philippines, outstanding department, a lot of information up there, in terms of temperature, in terms of the rainfall, etc. But what does a change in temperature, the change in rainfall, what does it mean on their livelihoods? What does it mean on the shelter? As my colleague here talked about, flooding in Sindh, resilient housing, how they should be changing it, how, in terms of displacement, what they should be doing about it. And the Philippine Red Cross is able to work with the different partners up there to say, okay, this is what the climate will be. But what is the impact of it on community? That needs to be translated and put down within the planning. Now, of course, that information is static because it's at that point of time. And we know that, the climate is changing, the information is changing, they are variables. So that is definitely one of the gaps out there, because a plan now in 2022 and a plan in 2025 cannot be the same, because again, there's a lot of changes happening within the next 3 years. But we need to be also updating that plan and see how the changes in the climate, the different variables will impact on people, on communities. Now, that municipal data, that municipal information also can help in going down to the local level, the communities, the wards, the barangays, and also updating their barangay disaster management plans. So that's one. So that's in terms of the whole long-term planning, long-term development planning, and the use of climate information. The second case study is more on the immediate, where I'll take you to Bangladesh, where we have in 2021 cyclone RDAS, which happened in May of 2021, that also within the heights of the COVID pandemic as well. That was another compounding risk. Now, the BMD Bangladesh Met Department is extremely good in terms of forecasting cyclones. So when they're able to forecast the cyclones, when it reaches cyclones wind speeds are at 125 kilometers per hour and above, it automatically triggers the Bangladesh Red Crescent's early action protocol. Like, okay, we got 125. This is something going to happen. It's going to happen in about 2 days. What should we be doing? So the Bangladesh Red Crescent Society, working with the BMD, working with the Ministry of Disaster Management and Relief, working with the Cyclone Preparedness Program up there, is able to say, okay, this is going to happen. What is the cyclone path? BMD has the path of the cyclone. So this is going to be affecting, Satkhira, Bagherhat, the coastal districts of Bangladesh. Okay, this is the path. Now, from the Ministry of Disaster Management, from the CPP, from the BDRs here, they have the information about the geography, the population, the different unions which could be affected because of the path of that cyclone. So we're having the technical aspect, and they're going to be overlaying it with the human aspect to say, okay, this amount of people are going to be exposed to that cyclone. This is the infrastructure which is going to be exposed to that cyclone. So what are we going to do about it? So automatically the whole preparedness planning or anticipatory action comes into it. Should we be doing evacuation? Where do we evacuate to? Should we strengthen our houses? Should we raise our houses? Where do we move our livestock to? What do we do about the pregnant woman? So those discussions start happening so that we are able to use the technical data into more human planning. Now, what we also see is in 2021, there was a double whammy because of COVID. Okay. Now, the whole aspect of, physical distancing, overcrowding, it was spread. Now, what do we do about it? So CPP, the ministry was able, because of the time available, was able to say, okay, we do have these approved cyclone shelters. Let's also increase the number of cyclone shelters by looking at, different stronger places. So we have multiple places where people can be kept in. That information, that early information, helps us to do better planning, better preparedness at the ground level. This is again with, in terms of communities, in terms these changing climate extremes. And I think that's an area we need to be also be looking at. So there's two in terms of long-term planning, how we're using climate risk information in terms of immediate. Now, what we're learning up here is the language. Okay. Now, and that's we need to be working on. And I think wherever we go, we've always been talking about this whole aspect of, you know, we talk two different languages. We need to be working together on it. And I think if it's being repeated out here, there is an opportunity. We should be doing more about it. The science community has that language. I mean, when I'm sitting out there, I'm listening to all this BAU, the data, etc., and it's like, it makes extremely little sense to me, to be honest. Now, and from a humanitarian development perspective, I see it differently. Now, we really, as Harsh also said, and Mr. Fogel said, there needs to be collective approach, needs to be working together. We need to come together, sit around the table, just like we were doing in Bangladesh with BMD, with the ministry, with CPP, with DDRCS, sitting down to say, okay, this is your data. What does it mean on a human aspect? What is the human face of it? And I think this needs to be done a bit more, because as we said, as Ruby said, data will remain data. And I think these opportunities coming here, understanding what RIMES is doing with the RDAS, to seeing that information and then seeing how it can be used in our development planning, how it can, you know, make communities the most vulnerable up there better prepared, better resilient for the next event, hazard event. So thank you very much.
Thank you very much, Colin. It has been an interesting discussion before the panel, how indeed we translate all these graphs, all this wonderful data into something that different sectors can understand. So we will deal with that as we go along the discussions very shortly. So we have one more panelist who will basically discuss on the same topic. So Dr. Michael Ernst. Michael, okay. Dr. Ernst is with USAID. He is the Support Relief Group Senior Hydrometeorological Hazards Advisor, Office of Technical and Program Quality. Michael, can you hear us?
Yes, can you hear me?
Yeah, please go ahead.
Okay, good. Well, fortunately, I am at the end of the panel, so everything that's important to be said has already been said, but I'll say a few words just from my perspective. And again, my name is Michael Ernst, and I am a Senior Hydrometeorological and Disaster Risk Reduction Advisor for the U.S. Agency for International Development, the Bureau of Humanitarian Assistance. Okay, with much of my career focused on South Asia. It is a real pleasure for me to be able to attend this workshop, albeit virtually, and learn more about the RDAS system. As you can see, I'm using a virtual background from the RDAS one-pager to help feel more like I'm present with all of you, although I would certainly rather be in the room with you and able to discuss many of these issues further. While I'm impressed with the progress on the development of the RDAS system, and I certainly agree with the goals and target users for this system, those being the international regional organizations, those really that can understand and provide data and feed into the system. The key for organizations like my own, and it was similar to very much what my Red Cross colleague has said, and is really the target organizations have to be able to get that actionable information to those who need it the most. And they need to be able to sit down and talk with those people and really figure out what is needed. Okay, and as the picture behind me suggests, how can this information help secure the water supply in the dry lands? These are the users that are the ultimate beneficiaries of this type of program. While this portal is an excellent start, experience tells me that much more work will have to follow in order for vulnerable populations to fully benefit from the information here. Alas, as we are firmly in the information age, we are also in the Anthropocene, where man is heavily impacting the planet's environment, including the climate. Systems like these are a useful tool in informing human efforts to reduce our impacts on the environment, including the design of nature-based solutions for climate adaptation, disaster risk reduction, and development to further promote the development of a more safe, secure, and sustainable environment. I am concerned that while information resources are expanding, resources to reach the most vulnerable with useful information are not keeping pace. So we will all need to seek creative ways to expand the reach of useful information, including information on the RDAS portal, as efficiently and effectively as possible. Thank you for this opportunity, and I really look forward to the rest of the workshop. Thank you again. Goodbye.
Yeah, thanks very much, Michael. So you've heard from our discussants. Any questions so far from the floor as well as online? Okay, we have one question. Can we give the microphone, please?
Thank you all panelists. I'm Dr. P.K. Mishra from NIS Government of India. My submission to the first panelist that you talked about the water infrastructures, and people usually talk about the commissioning of dams, right? But nowadays the dams are getting older and at risk. So do we have any policy on this decommissioning of dam? I mean, can you have some opinion on that?
Thank you very much, Prabsap. Actually, in Sindh province, we have terrain, flat terrain. We don't have dams. We just make some small dams for the recharge purposes. Otherwise, we don't have any major dam in Sindh, except one dam that's constructed recently, but it will again be said a small dam. These are not large dams. Large dams are constructed upstream in Himalayas, are in Khyber Pakhtunkhwa, are in Punjab, but not in Sindh. Sindh is a completely flat terrain, and we have been critical on construction of dams because they have their repercussions on the delta and lower rivers. So recently there are 2 dams that are under construction, but we hope that there will be less impact of these dams because we are looking forward for some water for environmental flows also. So in Sindh, we don't have any dams, large dams. We just have small dams for recharge purposes and for water harvesting. Thank you.
Thank you, sir. Thank you.
Yeah. Other questions from the floor? Yes.
I have no questions, panelists. I have a few suggestions. I appreciate the steps taken for the RDAS. It's a good step for providing common platform by compiling all the data. But it needs a vetting and verification of all the data being collected from different sources. Especially now time has come, I'm talking for the infrastructure, transport infrastructure. Time has come to go for the micro level designing and planning. Generally, I am talking about the vast country, India. Nowadays, we are planning for the entire country with a common specification, common color provisions. Now we are switching over to go for the regional or even district or small level. For that, we need some micro level data with verification and their projection. Prediction will be based on the verification of data, so which we need. It's the right time to think on.
Yeah, thank you very much, sir. So I'm calling Dr. Itesh to join us here so that he can answer also relevant questions. Other questions also we were not able to take on earlier can be accommodated now. So we'll be throwing also, I have some questions also to our panelists. So for now, Dr. Itesh, please. On the question of verification of data.
Yeah. So thank you so much, sir. I think for that, I think it's very relevant. I mean, when we are talking about a lot of data, we have to have the validation that to understand the quality of the data, and that is something that we have been trying to do for most of the data sets that we are using in any of these DSS tools that we have developed so far, and then going forward also we will continue to do that. Actually, I was just answering a very similar question. I think this is also a question from like Dr. Indira from Nepal, like again, the quality of the data is going to be one of the questions that we need to answer in the system when we do. So it's also to validate the source and the data that we are using. So in the system, we will have a component where we can both compare different data sources, and as well as we can compare it with the observed data sources, so that it actually provides a platform to see and understand which data, which of the models that are working well, because we have multiple sources of information. We have different global models. We have different regional models that are available, and countries have their own data sources as well. So one of the things that we will do is we'll keep all the data in the front for you as user to understand and analyze. And again, it is to, of course, to the need of the, I would say, the expert users who understand the data set. Then they can actually see, okay, we have 3 sources of information. One is matching very well with the observed situation, so we can use that more frequently. So these are platforms, these are things that the platform would provide as we go along. And we will keep what we call the WMO standard process for verifying and validating all the climate data sets that we are putting into the system. So yeah, so that is in the process, and thanks for that suggestion, sir. I think it is a burning question that that we had in mind, and we will keep that in the system as well when we complete the system.
Yeah, thank you very much, Dr. Itesh. Other questions from the plenary? Are there? Yes, sir.
This is a question to RDAS system, I think. Crop is very important. Crop data is very important, right? And whatever global data you are using, particularly this crop data, it is a very coarse in resolution, something around 10 kilometers, maybe 15, 30 kilometers. So how you accommodate all these things during your analysis? In case of micro planning, so local level planning, don't you think these are all lacunae one needs to be overcome?
Yes, so that's why we in fact the following discussion in the afternoon we would have a more detailed discussion on this particular question. Where so as we discussed in the morning, the regional data analytics platform is actually providing you a macro level information, so which we can see to understand how things are changing or varying in relation to the climate change aspect. More micro level information or data usage will actually be used or be done at what we are actually developing is the national decision support systems, which will be taking more granular information, both in a spatial scale. It could go up to a village level, or it can also be much finer time scale of information. We can say it is the 3 days or 5 days information, or it can be up to a season. So those are information that will be in terms of your planning and processes would be done at the DSS or the National Decision Support System level. But the data source would actually be coming from the RDAS platform as such. But the localized data that is needed for this decision-making process will be actually housed in the decision support system that will be done for each country, each sector separately.
And one more thing I just want to know that is RDAS has any provision of livelihood aspect, because the livelihood is one of the very important aspect to uplift the people, socioeconomically. So do you have any provision on that?
It's not yet there, but definitely, I think there are a lot of suggestions coming in terms of what data sets that can be integrated into the system. We started with few, and that is where we are keeping this platform is actually open to get suggestions from you. I think we heard about including gender aspect, livelihood aspect. It can be any data sets, and the system design is such that it can actually accommodate any data sets in that platform, and that is where we're heading. So we will not restrict any data sets that we cannot say that this cannot be integrated. or any format. This is also format independent. So meaning it can be any form that I think Harsh was showing, data in paper format. So if that data can be converted into some form of digital form, that can be also integrated into the system. So we are keeping it very open, and you as users of the system can suggest which are the data sets. I actually come from a technical background, so I don't understand a lot of this agriculture data or even the water resource data, but we have people who understand these things. So as the suggestions come in, we will actually integrate as we go along. So you will see over the next year or two, the RDAS system actually growing in terms of the data that it actually holds in its repository. So of course, we will have a provision for the livelihood data sets as well.
Thank you. Thank you for the response.
Thank you very much. We are actually going over time. So I have to cut the session short. So we have the panelists here. Basically, again, the idea for the RDAS session is to get forward ideas because we have a lot of data available. But again, the question of utilization of this data and converting it into information to what is usable to various sectors is the key towards making RDAS valuable. So I'm throwing these questions to our panelists. Colin is still here. Mr. Ayub is still here. I think Michael is still online. Mr. Anil is still online. If we can sort of provide perspectives from your end. We have gotten quite a number of perspectives from our plenary. And also the idea for RDAS moving forward is to get in touch with all of you regularly. Online meetings, etc., to introduce regularly the developments that we are doing for RDAS and get your ideas further on how to refine these products. So the regularity we will be discussing in a following time or whenever possible within today, but basically that's the idea, to connect all of us into making RDAS, to contribute our ideas, expertise. Itesh is saying he's having a very technical background. Of course, he has some sectoral exposures along the way of our work. He is more or less a hybrid person between all this data, analytics, etc., IT work, and a little bit of water, a little bit of agriculture. But there are a number of you in the plenary itself who are experts on agriculture, on water resources, on planning, on finance, possibly on infrastructure, on transport, who can contribute so much on going forward in RDAS, and we would want to capitalize on that, on this resource, because these are all resource. So the last question, if you can be fast about this, what are your perspectives based on your own experiences? Perspectives at going forward in better preparedness vis-a-vis both in the short term. Sir, you have discussed that the systems are not ready for immense rainfall. You have a normal rainfall for what, 2 months, 1 month at 200 millimeters. Suddenly at the beginning of the monsoon, you have 500 millimeters. So definitely the system is not ready to receive all that rainfall. Going forward, perhaps in your own perspectives at what you do, Mr. Pocrell, Michael, of course, Mr. Ayub, Colin, particular to your specific work, how could RDAS, what would be a specific product that would be, or a specific analysis? Because I understand that for many of us, a specific product may be vague as of now, but what kind of analysis would be helpful for you in order to do better at preparedness in your own fields, in your own areas, in your own organizations? Yes, Michael?
Yes, that is a great question, and that I appreciate that as part of the RDAS process, which is the most important thing, that you're really trying to open up, ask users what they need, and help co-create solutions to these problems. One piece that I think is of really extreme interest to a lot of us now, and you'll find a lot of the humanitarian community and the development community, as well as those that are just developing public infrastructure within their own countries, is this interest in nature-based solutions, and solutions that will be more sustainable, that will have less negative impacts on the environment, and that will also help reduce disaster risks. Now, these are relatively new, and they are all, actually, most of them being nature-based, are extremely vulnerable themselves. Those interventions are vulnerable and influenced by what will happen in future climates. So I would love to see RDAS used to try to help guide interventions that are in the line of nature-based solution, and also perhaps be able to look at with some of the data there, it's clear there's a lot of satellite imagery, a lot of climate data that could actually perhaps look at some of the nature-based solutions and how well they're doing versus other harder solutions, and also perhaps how they could be improved. How perhaps different species of mangroves could be selected in certain cases. Again, it depends upon the specific application, but it just is an area where there's a huge amount of learning to be really to be done to get this right, and to help all of the different communities that are in very different climatic situations. So I guess I would see that as one area where RDAS could perhaps really bring a lot of this information together to analyze what works, what doesn't, what are the limitations, and what are the real strengths and the keys to making these nature-based solutions work in the future. Over.
Yeah, thanks very much, Michael. We're noting that, and we will get in touch going forward on RDAS. I think Mr. Pokral is also raising his hand.
Thank you. As I told you before, we are a national disaster management organization, and we're not one among the users of the DSS, but it's an integrating entity that one can serve as a bridge between the national hydrometeorology institutions, including other technical early information generators, such as Ministry of Forest does the detection for forest fires. The Department of Environment does the detection of, again, clean air and air quality issues, and other sensitive sectors. And so as a NDMO, we are a key group producer, especially in terms of bringing in relevant data, impacts, past disasters, risk assessments, including hazard, exposure, and vulnerability, linkages between these three elements of risk. And as discussed in the earlier panel, again, down to a household level, disaggregated data on who within each of those houses live in, persons with disabilities, a lactating mother, a pregnant mother, ethnicities, elderlies. And these social vulnerabilities and capacities data are part of a common system where we work with the provincial and the local governments. And so that's how NDMOs such as ours can be an advocate for risk-informed decision-making and ensuring resilience of a nation's development efforts. What we see is the decision support system, at least in the case of Nepal, is increasingly becoming a buzzword. But it also offers a potential solution. It can serve as a flexible, scalable arsenal at the disposal of decision makers at these four different levels: the local, the district, the province, and the federal level, where DSS can take an advantage of the rapid technological innovations, these data systems, combining all these different sources of data, and also the big growing data that at times is too huge for meaningfully harnessing. So suppose like 10 years back, we couldn't have perhaps done it. The BIPAT portal in the Nepal case is an excellent example for again taking this decision support system forward. So what I would like to end by saying is this is an opportunity for us to really emphasize that DSS are a critical priority and the most tangible deliverables and outcomes that address immediate needs, as well as with potential to safeguard scarce investments within the region. And I understand, and from an NDRMA perspective, that this has to be prioritized and expedited. I'll stop here. I'll pass it back to you. Over.
Thanks very much, Mr. Pokral. Now throw the question to Colin.
Thankfully, I'm down the list, so I was able to think of the possible answers. I think 2 points. The first is, I was thinking around with on the website while you were displaying it, and there's so much of information, useful information out there. But how do we make use of it? And I think what's important out here is the whole aspect of, again, partnerships, as you mentioned it with Dr. Teshit, the capacity building of the end users, how to use that site. So before I would really expand that RDAS is how we use what is really out there first before we say, okay, this is what we need more. So I think, and with the Red Cross Red Crescent movement, you will be able to have that, regional outreach and a greater utility of that tool when it comes to both immediate planning as well as long-term planning. And I think building the capacities of one of the partners can definitely be helpful for it. That's one. The second is, I know it's going to be talked about in post lunch, but the information right there is more at the national level, and really the impacts, etc., we are seeing is at that local level. So getting down, zooming in to those wards, to those unions, to see what is going to be that impact of the data on them, and how we plan. We do that bottom-up planning is going to be essential. So I think these are the 2 points I think essential in terms of better utility of the RDAS. Thank you.
Thank you very much, Colin. I think we'll get better clarity as we discuss further this afternoon and delve deeper into country-specific decision support systems that will be linked to RDAS. But yes, capacity building is key. And that will be also, I think, the purpose of the regular discussions with this group moving forward in RDAS. So I think I'll move now to Mr. Ayub, because the recent floods in Pakistan has been very interesting. So your perspectives, sir.
Thank you very much. I already discussed whatever was my view about these flood disasters. As far as the RDAS use for found substance in Pakistan, I will suggest, as we all agree, that first thing is that we should raise the capacity of government officials to utilize the system, because whatever the system, we are not able to use it or utilize it, understand it, and there's no use of it. Two more suggestions that at the moment I had in my mind is that we would appreciate if the flood and drought risk map of Sindh province and applicable to whole Pakistan, and I will appreciate that too, is available to us. And also the impact of climate change on current agriculture practices. What will be the impact of climate change? Either the seeds or these varieties that we are using will be useful in the upcoming climate change positions or not. What will be the best way to deal with it if such type of information is available? And the third one is the poverty index district wise, if it is available, because disaster is directly linked to the poverty. So we must know that what is the poverty position in all districts of Pakistan. Thank you very much.
Thank you very much, Mr. Ayub, and thank you very much all for the very good insights. So again, we will delve deeper in the afternoon as we discuss the very country-specific, sector-specific DSS. And I believe we will have also very interesting discussions this afternoon. So I've been warned repeatedly to end the session. Thank you very much again, all. It's been wonderful discussing with you. So again, but this is, there's a lot of things moving forward, and I believe there's a lot of work for all of us moving forward. So now again, thank you very much, and I'm giving back the floor to Nika.
You, we'll just take a few moments to take a group photo with the panel members, if it's okay with everyone. Sorry. So
yeah, and I would like to thank also all the online participants,
can we ask
the discussants,
yeah,
as well as those who were listening to the discussion. So we have, again, almost 50 online participants. Thank you very much. So let us know when it's done. I believe people are ready for lunch.
Yeah, I'm sure everyone's hungry. So maybe invite everyone to please head on over downstairs for lunch, and we'll reconvene here at 1:20 p.m.
Yeah. So again, thank you very much, everyone. Lunch is ready.
Sorry, we'll have to cut lunch short because we're running a little late, and we really want to allot more time for the DSS breakout sessions later so that we could address everyone's concerns. So have a good lunch and see you all again here later. Thank you.
Hello. This is okay. Hello.
Hello again, everyone. May we please invite those who are outside to please get back in to, so we could start with the program, with resume with the program rather. Welcome back, everyone. We're already running a little late, so I think it's about time we start with the second segment of today's program. Very quickly, I'll just go through the proceedings of this afternoon. We'll start with a demonstration of RIME's developed decision support systems and care projects participating specifically in Bangladesh, Nepal, and Pakistan. And then we will go into breakout groups for in-depth discussions of these country-specific DSSs. Then this will be followed by discussions among the community. We would also like to acknowledge those who are joining us over via Zoom. We hope you are as excited as we are to learn more about our decision support systems. To start, may we call on Mr. Nazmul Ahasan Sean, DSS Lead of Care Component 1 with RIMES, to give us an overview of the National Livestock Advisory Services of Bangladesh.
So I think I'm audible now. So good afternoon, everyone. And first, I'd like to express my gratitude towards the distinguished delegates from Bangladesh, Nepal, and Pakistan. Thank you, everyone. So I will just briefly go forwards over the development of the livestock decision support system under this World Bank Care project. So how we actually proceeded towards the development of the system, and give a little bit of demonstration of the system, and then finally we'll wrap it up with the timeline of the next phase of development. So when we are actually talking about the decision support system, what do we mean by decision support system? Of course, it will support in decision making. It will not make decisions for you, right? So what kind of decision it will make? It will actually help the climate sensitive sector to actually make, help the decision maker to actually make decision regarding the climate sensitive sector. So we can actually think about this decision support system as a climate service. So basically what the DSS will do, will take the weather and climate parameter and incorporate those data with sector specific data, and provide some infographics and insight that is sector specific to you. So basically what it will do, it will take input from 2 different sectors, that is like weather and climate and sector specific data, and brew some magical elixir that will be drank by the decision makers, and they will actually make the decisions. Okay, so this is the basic idea of a decision support system. So when we actually tried to develop this livestock decision support system for Bangladesh, you know, this has never been tried before in Bangladesh. Of course, this is a very new area. So we actually faced a lot of challenges. So when we actually try to develop, so these challenges are bigger and then becomes a little bit smaller. So first, we actually find that there is no location-specific data for the livestock sector. So there is data, forecast data from meteorological department. There is projection data from global producing centers, but there is no sector-specific and location-specific data. Of course, this has never been tried before. And then there is insufficient management of data that is being collected throughout the years by Bangladesh Livestock Department. So those data is not properly managed, or so it was very hard to actually derive insight from this project, from this database. And then also there is like there lacks a scientific research how this weather information actually connects with the sectoral livestock data. So how this sensitive, how this weather and climate is sensitive to the livestock information specifically, and all these things. So the livestock sectors people are really busy, so they do not need to actually do all these calculations, how this one actually relate to this data of a livestock sector data. So there lacks a simplified portal, and also people in the field are not actually sensitized about this decision support system. So how they will actually use the data to actually make day-to-day decisions. So, so when we're talking about decision making, so what type of decision we want to make? So possibly we're thinking about 2 terms, 2 types of decision making. One is strategical decision making, and another one is tactical decision making. So those decision making will be for reducing the risk and maximizing the benefit from the favorable weather condition, of course. So for example, when you're talking about strategic decisions, those are long-term planning for adapting with this changing climate variability, and tactical decision-making is like for day-to-day management. So when you try to, for example, the pipeline of decision-making could follow something like this. When you actually try to develop the system, we thought of something like this one. So the weather and climate information data will come from national meteorological services and global producing centers. Then there will be a decision-making engine or a DSS, and human layer must be present because those decisions must be verified before going to the public. So on the top of there is some of the sector that we thought that we can actually do some strategic decision. On the bottom there is like the decision that we can actually do to day-to-day management. So for example, these are the sample decision points that we thought for fodder management. So selection of location-specific suitable fodder based on the climatology, plantation of fodder, seeing the seasonal forecast. If there is going to be more rainfall, then we should move towards different alternative fodder format or silos, and storing and packaging. And also we need to consider about the commercial farmers because they need to be a coherent system. So when I actually tried to find out the stressor of these climate information, so we actually listed very few but very crucial things that actually putting the stress towards the production of the livestock sector. So for example, humidity, floods, heavy rainfall, high wind, dampness due to continuous rainfall, and extreme temperature. For example, high temperature actually plays with the respiration rate of the livestock and poultry, and also the production as well. So when we actually tried to make a decision of the system, we thought it will be actually very good to make them into an integrated manner, such as so that we can give them alert. So based on those alerts, the decision maker can actually act on this. So for example, this is an study that they actually did to find out the impact of the climate change on livestock. So all these things actually ultimately results us to the reduced production. Okay, so this is very clear that there is a impact of climate and weather into to the livestock. So when I actually tried to put all these things in a simplified manner, we found out that some indexes actually being tested over the other side of the world, for example, Australia. So they actually put this thermal humidity index that is very good indicator of this stress. And we also found out that 48% of our livestock, cattle livestock, is actually crossbreed of Australian breeds. So we thought, okay, that example can be applied to our country as well. So because this is similar breed. So for example, if the THA is between 72 and 78, the cattle will be in mild stress, and between 79 and 88 it will be moderate stress, and the stress goes higher, and at a certain level the cow is dead, you can see. So this also works very well with poultry sector. So this is the summary. This also works very well for the poultry as well. For example, you can see there is a band of temperature and humidity where the poultry is actually comfortable. So if that is between this range, okay, so the production actually goes down. So these are the effects that is having from the thermal and humidity index. So we also tried to list out, tried to find out actually the effect of severe events over livestock. For example, the cold wave actually causes respiratory illness, calf pneumonia, so this kind of things. And flood also causes anthrax, foot and mouth diseases, and various other diseases. So to summarize this, what you try to do is like put in terms of very simple indexes so that the decision maker can see in a system and know where actually they need to act on, and which poultry or which livestock they need to act on. So to make all these things, we actually try to build a decision support system with these three simplified categories when we're building the product. So climatology and location-specific weather advisory into the system, adaptive measure for extreme events. When a flood event occurs, what we need to do. When an extreme heat event occurs, what the extension worker need to do, and in threshold or index-based advisory. So we started with these teachings. Okay. So far, what we have done is like integrated these things into this simple format. We integrated real-time meteorological services forecast into our system. Also the SMW focus into our system, that is a global source, and extreme event-based alerts, integration of historical climatology to see which area we actually use to actually for planning, and disease analytics and monthly advisory generation. This kind of thing. If you would like, I'd like to show a small demonstration of the system. So at a glance, this is the livestock advisory system for Bangladesh. The link is nlas-wb.rimes.int. So when you look at the system, it is actually showing at a glance if there is any alert in your country. So for example, we can clearly see there is two locations. The location means Upajala, sub-district level boundaries, and we have 2 rainfall alerts and 477 thermal and heat index alert. So if we want to know when this is actually happening all over the country, we can actually look over the time. You can see there is like these are like 3-hour focused. So we can see that there is 6-hour window where some of the places in Bangladesh is actually getting mild to moderate stress, right? So the question is where? So if I just go down there, I can actually see where we are getting mild stress and where we are getting severe stress, right? This is presented in time and also in space. Okay. So if I want to look at this in a very in-depth detail, what I can do is that from the left side, I can go to the weather and click on alerts. So for example, earlier there was places where we had 2 rainfall alerts. So let it load a bit. You see? So the rainfall alerts are in this and these superjournals. So for example, if I click on this superjournal, this district, it will load all the sub-district in here and show where the rainfall alert is happening. Okay, so these are the places where the rainfall alert is happening. And this, if I click on here, you can see it is happening on 19th. Okay, so we have this granular level of information present in the DSS. You know when it is happening, you know where it is happening, you know which specific location unit you are happening. So when a decision maker or a national level livestock worker sees, I need to direct some of my worker into this location, and with some small advisories, then this will be much helpful for them. Okay. This is the basic idea of the livestock. Okay, so also there is like, we saw alert for the livestock, so the THA-based livestock alert. So I just want to show that alert. Let it load. So these are the places that we're having moderate alert, and these are the places we're having severe alert. Okay. So if I click on this district, so these alerts are actually showing the highest alert within a sub-district. So if one of the sub-district is having severe alert, it will show on top that there is a severe alert of that district. So for example, this district, not all the upajalas are having severe alert, but only one upajala. So that is showing that one of your upajala has severe alert. So there we can actually prepare and do some work. So on addition to that, we can actually look for the focus components. We have actually incorporated real-time Bangladesh Meteorological Department's focus data. When there are model updates, it automatically updates in our system. The interface is already been done, which show very transparent API. So if I want to look at some weather forecast, we have iconography-based focus. So it is actually very difficult for us to understand the number. So what we try to do is like put whatever is possible into the system. It is in numeric format into a graphical format, so that people, when are looking into the system, understand the implication of focus by just looking at it. So in addition to that, we try to actually implement a small climatology section to understand how our climatology is progressing. So for example, in this year, we can see this is the station-wise climatology for using Bangladesh Meteorological Systems observation data. So when we are looking into the system, we can see that in the last August, we had very severe deficit of rainfall in Dhaka. Okay, so and also the temperature was almost close to normal. So we can see how our climatology is progressing. So if there is a drought situation, we know what is our current situation and we know the forecast. Okay, so we have this current intelligence and we also have the forecast projection. From there, we can actually decide from a decision point of view what to do next. And on addition to that, we actually try to integrate the decision analytics, disease analytics. So where we will actually find the FMD, like foot and mouth disease, that is one of the prominent diseases in Bangladesh. So we can actually cluster the disease and find out where we actually need to do the vaccination drive and give out the advisories to the livestock worker to do preventive measures. So for example, there is one interesting insight that I want to present. If we actually do this season-wise cluster, so for example, when it is winter, you can see that foot and mouth disease is actually contains in this area. So if we actually progress towards the season, if we go to the winter, then pre-monsoon, it goes down a little bit. And again, the monsoon, it increases a little bit. And then in the post-monsoon, it increases much. So why is this? So because this disease actually happens most after the flood. When the monsoon occurs, then after pre-monsoon, then it spreads very much. So this kind of disease analytics is there. So you can identify where the hotspot is and do your work based on that. And on addition to that, we actually try to integrate the monthly advisories. So go into the system. So for example, when a heat wave bulletin occurs, we can actually generate this granular level advisories. So here we can see that it is in Bangla because it is in local language. We try to focus on that. So we have actually advisories for cattle like cow and buffalo. And then we have advisories for goat and sheep. And then poultry like chicken and duck. And also you can see there is like one commercial sector and one like end user, like end farmer. So marginal farmer. So we try to actually categorize this according to the farming group and according to very granular levels. So using the data from RDAS, we are getting the data, regional data into the RDAS. Then using those data, we can make this kind of granular level decision at local level. And the last thing that I want to show is the climate projection. So we saw that how the past climate has been working, and we can also do the climate projection. So we know from the climatology section, we saw how our climate has been progressing. And if you want to know how the climate will be, you can actually see our climate, next climate formula. For example, if I want to see total daily rainfall, what is going to happen in October 31st to October 1 to October 31st, then I'll select, because this is an ensemble forecast where divided those into 5 quantile, and we can actually see the outlook from here. So this is going to be the outlook for the next 1 month. We know what happened in last 1 month. We know what will happen in next 1 month, and we can come to our decision based on those analytics and information. So this is my short presentation regarding this endless livestock advisory system. I would love some comments from you guys. If you have any questions, we would love to answer.
Thank you very much, Nazma. I'm sure there's a lot of questions from our participants, but we'll be getting into those later during the breakout discussions. So for now, may we call on Dr. Dilip Kumar Gautam, Climate Application Specialist of RIMES for Care Component 1, to present the DSS being developed by RIMES for Nepal, specifically DSS for the National Disaster Risk Reduction and Management Authority and the Department of Hydrology and Meteorology in Nepal. Dr. Dilip.
Good afternoon, everyone. I will briefly present different support system for flood and weather forecasting for the Department of Hydrology and Meteorology, and another decision support system for disaster management for the National Disaster Risk Reduction and Management Authority of Nepal. And then we will also give you a glimpse of the DSS by showing you the live demonstration. Next, please. So for DHM, we are focusing on developing decision support system for flood impact forecasting, as well as weather forecast verification and bias correction. Presentation will consist of DSS development purpose and current status, and next steps and sustenance mechanism. For National Disaster Risk Reduction and Management Authority, we are focusing on developing multi-hazard early warning system tool. So here also we'll be focusing on DSS development purpose and current status, and next steps and sustenance mechanism in this presentation. Next, please. Next. The DSS development steps are the following. In first step, we conducted gap analysis through DX review and user need assessment processes. And then in next step, we interact with operational user decision-making process, recommendations obtained from operational users. And then in step third, the decision support system components are designed and prototype system is being developed. And after getting relevant data from the climate, weather, climate, and hydrological data, as well as sector-specific data, then the DSS system would be fully developed. And then fourth step is the deployment of decision support system on premises of beneficiary agencies and provide backup support for a smooth functioning of the DSS. Next, please. So existing gaps for the decision support system at DHM are no operational impact-based flood forecasting system available yet. No systematic weather forecast verification process established at DHM. Need to improve forecast performance, especially for finer resolution, both spatial and temporal resolutions, to meet stakeholders and demands. Recommendation from Department of Hydrology and Meteorology were obtained as follows: impact-based flood forecasting and pilot testing in Bovai River Basin, weather forecast bias correction methods, web portal for weather forecast verification, and interface to support public warning services to agriculture, transportation, water resources, and disaster management, and support with different range of products, including nowcasting. Those recommendations were obtained during various discussions with the Department of Hydrology and Meteorology. Next, please. So, based on DHM's recommendation, there are two components. One is a hydrological component where observed and forecast data are integrated into a flood forecasting system, and hydrological and hydraulic modeling. So that gives us a hazard forecast, and then potential impact forecasting based on integrating exposure and vulnerability data. So this we are piloting in a relatively small basin, around 3,500 square kilometer basin, that is Bovai River Basin in western part of Nepal. And another component is related to meteorological forecasting. There we plan to introduce forecast verification and bias correction methods, and develop visual platform for real-time forecast verification and seamless integration of corrected and improved weather forecast under the flood impact DSS and other sectoral decision support system. So once we will have a corrected and improved weather forecast available, then we would like to utilize those corrected weather forecast for generating corrected flood impact forecast, as well as those corrected weather forecasts would also be integrated into the decision support system that are being planned to be developed for other sectors. So, for example, agriculture, transportation sector. Next, please. So this diagram presents the schematic of the proposed flood impact based forecasting system. So you can see here in the left side, there are three kinds of data required: hazard data, exposure data, as well as vulnerability data. And the risk is the combination of these three elements: hazard, vulnerability, and exposure. So in hazard data, mainly we'll have discharge as well as water level forecast, and then flood inundation forecast. So those will be obtained from hydrological and hydraulic modeling. And then for the hazard prone areas, we have to collect exposure data that may consist of population and demographics, roads network, building and infrastructure, land use, and other data. And then for those exposed elements, then we'll do vulnerability analysis. And after combining these three kind of data set, we can get the risk assessment, and finally, we can produce impact maps, reports, and advisories, and those would be disseminated to the end users. Next, please. And this figure shows the proposed forecast interfacing system, mainly weather forecast interfacing system. Here, we'll have a local observations from in situ observations from observation network of Department of Hydrology and Meteorology, as well as other data sources will also be utilized, global observations and the satellite-based observations, radar observations. And then there will be forecast data set as well, local forecast obtained from Department of Hydrology and Meteorology's numerical weather prediction system, as well as regional and global forecast. For example, forecast obtained from IMD or India's National Center for Medium Range Weather Forecast, ECMWF, and RIMES forecast. All those forecasts will also be integrated into the system. So then there will be API developed to pull those forecasts from different sources to the decision support system. And then further data processing will be conducted. And after processing data and comparing with the observation forecast, comparing forecast data with the observation data, we'll get the error information, and we'll verify whether forecast is of good quality or not. And we'll develop that forecast verification method for both kind of continuous verification or categorical verification. And then once we'll have a verification, then and we'll further develop bias correction methods to generate bias corrected weather forecast products. Those weather forecast products will be useful for public weather services, as well as to use in the decision support system for various sectors. Next, please. So let me now focus on hydrological part, that is a flood impact decision support system. Here, the first important thing is to generate hazard information. So that comes from hydrological modeling as well as hydraulic modeling. So for hydrological modeling, we need good quality rainfall data. For daily and hourly hydrological model, we have developed hydrological model for 2 time scale, one daily and another hourly time scale. Since Babai River Basin is a relatively small river basin, its catchment area is around 3,500 square kilometer, and we have divided it into 6 sub-catchments, and some of the sub-catchments are really small catchments, and their time of concentration is several hours only. So in that case, we need hourly rainfall data to capture the flood peak. So we are developing hourly hydrological model as well, and we use satellite data to fill the gaps in observed data sets. And both daily and hourly hydrological models are calibrated and validated. And then next step is DSS development by enhancing the interface and dashboard and updating model integration. Next, please. Next, please. And the next step is once we have a hydrological modeling that gives water level and discharge forecast that provides the boundary condition for hydraulic modeling, that is for inundation modeling. And next step is developing that hydraulic modeling part And we are working on that, developing a hydraulic modeling part that gives flood inundation maps, flood inundation information. So that is the hazard modeling component that we want to complete within second quarter of 2023. And then after that, in the meantime, we will be working on collecting exposure and vulnerability data, and then we'll conduct impact modeling, and those information will be integrated into the DSS interface, and DSS interface will be enhanced in the first and second quarter of 2024. For web portal for weather forecast verification, in the first to third quarter of 2023, we plan to develop weather forecast verification and bias correction methods, and web portal for verification and bias correction will be developed in the first and second quarter of 2024. For sustaining the system, since whole process is a code development process, we engage actively the Department of Hydrology and Meteorology, and the system will be deployed at National Data Center or on premises DHM, and backup support will be provided continuously, and there will be regular capacity building of DHM technical team. Next, please. For impact-based multi-hazard early warning system, decision support system for National Disaster Risk Reduction and Management Authority, I will briefly present DSS development purpose and current status. Next, please. There is currently no operational multi-hazard early warning service in place at National Disaster Risk Reduction and Management Authority. So National Disaster Risk Reduction and Management Authority recommended an impact-based multi-hazard early warning system to support disaster preparedness relating to 4 critical hazards: lightning, forest fire, flash flood, and landslide. So we'll be focusing on these 4 critical climatic hazards. Next, please. So the support to National Disaster Risk Reduction and Management Authority in development of a decision support system for impact-based multi-hazard early warning will consist of customized warning information for flash flood, landslide, forest fires, and lightning. And we'll be integrating multi-hazard early warning system, decision support system to the existing BPOD portal, and then developing the common alerting protocol for dissemination to various user agencies. Next, please. Yeah, this is the schematic diagram of the decision support development process. Please, next. For lightning alerting, we are currently doing data curation and processing, and trying to generate advisories, 35-minute of lead time, and it will give 48-hour outlook also based on flash count. For application development, we have initiated the development of interface and dashboard, and updated real-time observation and short-term forecast integration. So you can see here the screenshot of this Satark Nepal support system. Next, please. Yeah, the hazard engine would consist of flash floods, lightning, forest fire, and landslide hazard information. And the impact analysis will be based on integrating hazard information to the exposure and vulnerability data, which are available at NDRRMA's BPOD portal that we intend to integrate on the third quarter of 2023. And in the first and second quarter of 2023, we will be formally generating CAP enabled alerts And the application development will also be start on the second quarter of 2023, full development. Actually, the prototype is already there. The full development will be on 2023. And since this is a code development process, the technical team of NDRRMA would be actively engaged in the process. And the DSS will be deployed at national data center or on the premises of NDRRMA, and backup support will be provided regularly. And there will be regular capacity building of operational team. Next, please. So now I would like to demonstrate a prototype of these support systems. Yeah, this is the decision support system for the Department of Hydrology and Meteorology for flood impact based forecasting for Mumbai River Basin. Here you can see the forecast, that is the QNEH forecast, that is a discharge and water level forecast in forecast. Yeah, there is a 3 days daily forecast as well as hourly forecast. So we can see here some data for two stations, and then another menu would be river morphology, where data is to be filled up, and similarly flood hazard mapping that comes from inundation modeling part, and then impact and exposure data. And after combining all these, you see hazard forecast, water level and discharge forecast, as well as for inundation depth forecast and impact and exposure data, then we'll get next information. So yeah, let's move to another. Yeah, here we have this more than 4 hazards information are already we have thought of integrating here, but currently we'll focus on lightning advisory system, and then flash flood advisory, forest fire, and landslide advisory. So in future it could be further expanded in earthquake monitoring system, and then other heat wave, cold wave as well. So this is the this is the lightning advisory system. So lightning is a serious hazard for Nepal. Yeah, based on different sources of data, meteorological forecast data, lightning forecast data. So it displays real-time lightning hazard information. So it gives nowcasting, as well as based on short-term weather forecast, we can also get lightning forecast. You can see here lightning somewhere outside Nepal, somewhere in southern part of northern and southern part of India, northwest part of India. So there is no lightning flash there. So the menu consists of weather forecast, recent lightning events, nowcast, advisory, and report generation. So similarly, for other hazards also, we are generating advisory based on your information as well as weather forecast information. Thank you.
Thank you very much, Dr. David. Just reminding everyone that we will be having breakout group discussions on the DSSs immediately after the demonstration. So please hold on to your questions or comments until then. so it can be more properly addressed later by our experts. For our last DSS demonstration, may we call on RIMES IT expert Mr. Kamar Munir to present the specialized expert system for agro-meteorology early warning system for Pakistan.
Thank you so much. So, in shortage of time, I quickly jump on the demo presentation. So, system, we are developing tool for two provinces, for Punjab and one for Balochistan. Okay. Sure. So one for Punjab and one for Balochistan, and these two systems are same, but the agriculture zones and different crops and different regions, they are a little bit different. So this is a live application. You can go system.rimes.int and you click on that like Punjab part, you will get here. So you can see here the dashboard thing in which you can see the season, the current season which are going on. So currently in Pakistan, Rabi season started from this month, and Kharif season is going to be end, and is like cotton is to be picking stage. So the season which is started, so most of the advisory for that. So it is automatically generating from here which season is getting to there, and also their next highlight is a seasonal forecast and then monthly forecast. And these forecasts are coming from local meteorological agency like Pakistan Meteorological Department, are main source of all the weather and climate data. And if you go on the down part, you can see there's a map here in which you can see that Punjab, what is the outlook of Punjab currently right now. So this data is current data is coming from the Pakistan Met Department and shows what is happening right now over there. There's data from their observatories and automatic weather station, so we can have a look what is current status over there. If we go on the next tab, we can have a 3-day forecast, and this is a forecast on the numerical weather prediction. All the simulations are at the Met office, which is upgraded at two times, like twice in a day, at D00 and D12. So all if we go on the next thing, we will see the monthly forecast. So this is monthly forecast. This is automatically linked to the Met office, and whenever they give the monthly forecast at the end of the month for the next month, so it should be there with the impacts. So also we can see the outlook for the anomaly outlook, what is happening for this October. It's shown is a below to normal to below normal rainfall to the Punjab and most of the part over there. Also the impacts are showing here. What are the impact, like soils have enough moisture to proceed for the time sowing and healthy growth at the initial stage of Rabi crops. So we can also look into the seasonal forecast, and this seasonal forecast for next 3 months. And this is also coming from the Pakistan Met office. This is also showing what is happening in next 3 months, and on the basis of that, the agriculture extension workers and farmers can plan their activities with a consultation of our Punjab Agriculture Department. So this is a weather part. Like if we go on the outlook, we can also have 3-hourly data, and this is also forecast data from Met office, like all the parameters which is necessary for the agriculture, like rainfall, humidity, temperature, average, and wind speed. Lot of the parameters there, but we are showing right now this. So for the crop panel, we can see the crop panel here, where we have a list of the crops to at the different regions. So if we go over there, we can have a list of all the at the district and the sea levels for the Punjab, and we have, if we want to select any, we can have the crops. So currently I'm showing two crops here. One is cotton and one is wheat. And using this crop panel, we can have the crop stages, and we can have a crop list activities on the basis of that. So on the basis of all the information from the crop information is coming from the Punjab Agriculture Department. We have two sets of data. One is met data, weather and climate data, and other is crop data. So after all these data, because before the gap is there, because there no data-driven repository was there before. So the departments from two different departments have one repository, so they can have a decision making through there. So if we go over there, we can have if we select any of crop, and so on the basis of all the information from crop and meteorological data, we can have an advisory to farmer. So this is a dynamic one. So it's coming from like from the last season, we have that information in our system, and we have also seasonal information. We have also which season is going on for the crops. So basis of that, we have advisory there. So this advisory can be used by the extension worker to send to the farmers. How can they plan their activities? So the way forward on this system to make a design for policymaker, and the policymaker should also have a decision maker from this system. And also the way forward for this system is having more UI based. Next thing is sustainably. Is this system will deploy at they have three options. It can maybe deploy at the department which you are using that, and they will maintain that. And next option is cloud-based, which can be deployed at the RIMES in here, Bangkok, and IT team can look after it. Another option is a national data center, which have Ministry of IT in Pakistan, and they can manage that. So that's all. Happy to answer any questions.
Yeah, thanks, Kamar. I'll just probably take 5 minutes to sum up the DSS development process that we are taking for different departments, different sectors in different countries. So Sesame is something that we started very early in 2015-16 in Myanmar, and from there, what we have learned, we are actually trying to replicate into other countries. And what you see here is basic, very preliminary things. And as we go along into the development process, we would actually have a lot of information. What you saw in the livestock system in Bangladesh is actually gone through a lot of discussion with the livestock sector itself through the technical working group. And that is what we're actually proposing in each of the DSS development process. Under CARE, we do have the provision to have this technical working group where we will actually get more detailed information from the sector in terms of the requirement. So like for Punjab Agriculture Department, I think you know more about the crops, the climatology information that can be fed into this system, where you can guide the development team. And you did mention yesterday that when IT guy sits, you will develop the tool, but he doesn't understand the backend on the agriculture aspect. And that is where this working group would be really crucial in terms of what we put into the system and how the information in the system would be performing. And that, I think that is the thing that we are doing in the next session in terms of getting input from you, what we think can be added in it. And in a sense, we are also trying to bring out more analytics and services like we did in the RDAS system or what we are doing in the livestock system in Bangladesh. And you actually see very similar analytical platforms in whether it's the Nepal DHM tool or the India RMA tool or the agriculture tool. So this is the beginning with some of the components, and as we go along there, the improvements and things will be added. And what we want from you now is what exactly you think are going to be products that you want to see in the decision support system, which will be discussed in the next session. So yeah, just thanks Kumar for that presentation.
Thanks very much. I'll jump directly because we are late and we have to finish seriously the working group discussions because your inputs would be very, very important. Thank you very much to all the presenters of the tools and the, who also demonstrated the current capacity. These are the very beginning of the tools. We have done some work, but again, the inputs at refining it, we will really, really need everyone's cooperation, everyone's expertise, data available, prioritization, and we will look at that as we go into the working group discussions. The working group discussion will focus only on 3 questions. So particularly for component 1, focus institutions. So we have Pakistan, we have Sindh Irrigation Department, we have Punjab Irrigation Department, Balochistan Agriculture Department, and we are looking at also, of course, MOPDSI. Possibility of also of articulation of priorities for Pakistan Meteorological Department. Of course, Nepal, we have also priority institutions, the same as Bangladesh. So we will look at this guide questions. Sorry, we will have to request everyone if it's okay, but it's actually an imposition now because again of the time. So we will request everyone to just get coffee, tea, whatsoever refreshments together with while we do the working group discussion so that we can save on time. So these are the questions. So we will look at your critical decisions. This is an example for the agriculture sector. You can use the same question, but for a different sector, say water resources, say livestock, say disaster management. This is a process of refining. Again, the system is available, but exactly what product should be delivered to you is the question. You will see a lot of data, but at the end of the day, you will be asking, sir, how is this information relevant to me? That information will be different from the requirement of the farmer, because the farmer will have a different level of decision making, a different level of planning. For you, you are managing institutions, you are managing people. For farmer, he is managing his crop. He is managing his resources that are allotted for the crops. He is managing his machines, if he have machines, etc. He is managing his major resources. So yeah, can you go down? I think there are other, yeah. So we have to identify long-term plans, decisions for different stakeholders. For agriculture, again, if we are looking at decision makers, say at the province level in Pakistan, or at the national level, say in Bangladesh, we are looking at also other stakeholders. So it's not only one stakeholder per sector. It can be also the farmer. It can be the extension worker. So we have to identify that. Next one. So identify medium-term plans and identify short-term plans and decisions. I will explain this later when we go to the example. Yeah, go ahead, Gunnar. Next one. In identifying this, we have to be very specific. Which crops? Because for Punjab, for example, you cannot just say that for crops, because you have a variety of crops. But for those crops, which would be your most priority? Of course, you would want to include all the crops. But if we can take on for now the most priority, and then look at the others later, that will be great. The perspective being that we can start from somewhere. If you can include 5 priority crops, That's fine, provided that we have all the data we can access, integrate into the system so that the system can provide analysis for you. Absolutely fine. Okay. And who is making that decision, etc. Again, I'll provide an example later. Go ahead. So identify information requirements for supporting such decisions. Next one. Okay, so identify per required plan for analysis of crops at risk for future climate. This is for crops planning. Identify in which form this information requirement should be presented, depending again on your requirements. For farmers, this may not be applicable because farmers do not do 10 years planning. They are only doing what will be happening tomorrow, what may be happening 3 days from now, but they don't plan 10 years ahead of time. However, for crops planning, this will be very relevant because if you are looking at increases in temperatures in the future, the question is, would current priority crops be able to sustain fluctuations in temperature in the future to sustain high production? Again, if you look at Pakistan, there have been recent heat waves affecting mango production. Okay, next one. And through which mechanism and how frequently should this information products be communicated to you? The tool can push whatever information into, say, mobile application, but this may not work for farmers. This may not work for farmers. It is able to push information through the DSS itself, but for those located, say, in rural areas without laptops, it may not be possible. It may be difficult, or where internet is low, it may be difficult. But for you in the offices, it will be easy. So in other words, for every level of user, you will have every level of requirement and every level of mechanism. So we have to identify that also. So depending again on the user, for farmers, possibly text messages, possibly voice broadcast as identified in most areas in local areas in Bangladesh. Again, we already have some outcomes from the assessments. We are now just refining what you want, what is needed for different levels of decisions. And we have to validate that also as we go along with experimental products. Okay, and identify the frequency and delivery of information. Yeah, Art, go ahead. This guide question should be able to fill the next slide. Next, Art. So for example, for agriculture, you will have various users. You may have 2 users. You may have 3. It will differ from country to country, sector to sector. For now, you may identify also only 1 user. It will not be a problem. But the important is, as you identify the user, you have to identify the key plans and decisions. Because again, the purpose of the tool is to be utilized. Whatever information the tool is capable of providing, whatever capacity the tool has, will have no value if eventually it will not be utilized. So for example, for the state departments, long-term crop planning, you're talking about 5 years, 10 years, 20 years. Maybe you can engage research institutions on how to develop more temperature resilient crop varieties. You can do so much with information that are available, both climate and sectoral. And then immediate and short-term farm decisions. In here, in this diagram, you can see the huge disparity between decisions that are undertaken by government leaders and by the farmer and extension workers. In there, you would be looking at analysis at crop risk to future climate, meaning increases in temperature, possibly higher variabilities of rainfall, more extreme events in the future, and how to develop more resilient crops in the future. For the extension workers and farmers, it may be looking at harvesting in the next 1 to 2 days. If you are expecting a cyclone to affect one area in your country, and if it's viable to harvest, then it's a win-win solution. You have to harvest, given advance information through which mechanism. So this all, again, level of decisions depends on your level of mandate. Can we show the Word file? Actually, the exercise, we're trying to simplify as much as possible on the exercise, such that it's only providing answers to a series of questions, as I have shown, but it's like this. But we have also indicated capacity building requirements, if there are any, from the National Met Services. So for National Met Services that are around, so please identify also, let's see how it goes. And then for the sectoral institutions, go down, yeah. So planners, decision makers, again, going back to the questions, I'm just putting it in a tabular form so it's easy to identify. Who will be the specific users of your DSS? So you will have to provide that information. Again, this morning, even in the RDAS, you are saying who will take the decision, what would be the products. The refinement of the product depends on who will use those products and how you are going to use it, and how much data are available for integration into the system. Okay, key plans and decisions. What are these specifically? An example will be provided to you. It's been printed, so you can just view later during the working group discussion. Okay, information requirements for enhanced risk and resources management. Remember that climate is usually a resource. We are only looking at it as a risk when we are having extremes, when there are impacts, but climate most of the time is a resource. We are moving every day, going through everyday weather. What are the information that would be critical for climate information, informing your plans and decisions? So when we are saying, for example, what information that would be critical, for example, for harvesting rice, a critical analysis would be, will my area be affected? How much rainfall will I be receiving? Of course, there would be uncertainties. How many days of rainfall would there be probably? And et cetera, et cetera. The same as flood. What is the level of flood that will be anticipated? How possibly fast the water will rise, etc. Of course, again, there are uncertainties to the answers of those questions, as well as to the products that will be generated. And how would this information products, how do you want this to be presented to you? For example, if you are saying we want information on rainfall because we are harvesting our basmati rice is about to be harvested. How do you want that presented to you? Do you want it in graphical form? Do you want it in text message that can easily inform you that there is highly likely rainfall? Do you want it in similar form earlier when there was simulation of the rainfall that was captured for the Pakistan extreme rainfall during the monsoon? So these are things that we have to provide clarification on, in what form, because it's very easy to say, give us information, but in which form would it be easiest for you to understand that information? Again, it would differ from user to user. Decision makers will say, okay, I'd want this in color graphs and all. Because we experienced that in Myanmar. We thought, because at the national level, they were telling us, oh, we need graphs with various colors on the level of rainfall. And then we went to the farmers. because it was so colorful. It's easy to use by decision makers. You see the quantum and the rainfall, etc. And then suddenly we went to the farmers and the farmers are saying, we don't understand any of this. Can you just write it in local language and send us via SMS or announce via local loudspeaker, etc. So these are the things that we need to understand. And the channel and frequency of information dissemination and feedback. Again, I'm saying mobile phone, I'm saying mobile app, I'm saying computer, I'm saying SMS, but we have to refine this for various users. There is no limitation also as to identification of how many channels per user can be identified. It can be identified as many as possible because again, the tool can just push information as easily as that. So we will depend on you very much to identify these levels of priority as well as our country coordinators and other relevant members of the team will be explaining also as we go along other requirements for us to undertake this process. So I'll end here, and then if it's possible, I know it's maybe too much to ask, but if we can finish in 30 minutes and then present per country as soon as we can so that we can sort of complete the session quite early today. That will be very much appreciated. So any questions at this time? Are we clear with the exercise? I suppose? Or are we all very sleepy? I hope not. But in case we have questions, we are assigning members of our team to each group. So you can just ask the questions. Also on the demonstration earlier, members of the teams will be there to answer questions on the demonstrations that you have seen earlier on the tools. So I think we can have one group here. Pakistan can be here. So if needed, we can join the tables, but otherwise we can stay on one table. So Nepal can be here and then Bangladesh can be here. Again, as needed, our country coordinators and other members of the team can facilitate. The printouts are available for facilitating the discussion. At the end of the exercise, we should be able to identify in the diagram as well as in the tabular form those elements, because that would be important. We are not saying it's the final products. What we are saying is that if we are coming up with experimental products and improve it later, we need to start from somewhere. And we have to understand the requirements better. Because again, we have an initial understanding, but there is always room for refinement. Okay, thank you very much.
Okay, just to recap, the breakout groups are divided per country and each one will be facilitated and led by a RIMES expert and a country coordinator. Each group has about 30 minutes for discussions. Following this, we will kindly ask a representative from each group to briefly discuss the findings from the discussions. For our participants from other countries, please feel free to join the sector that is most relevant to your work.
Sorry, I think I missed out on something. Other stakeholders from other countries, please feel free to join any group that are relevant for you. Transport sector, Bangladesh has transport sector, Nepal has transport sector. So there would be discussions on that. So please feel free to join because I think while you are not part of these countries, there might be some discussions which could be relevant for you and where we can learn from you as well. Livestock will be Bangladesh. Yeah, thank you so much. Pakistan would have agriculture. Thank you so much. Okay, we are Jay and Itesh.
د نورو په ځان دونه خواري کړې دي بم یا به څوک ګوري یا نه راړو څوک ګوري نه دی دا زکام نه دی ملګری دی لاړله هغه لاړله او نه نه نو ته ملګری خپل دي نو راځه مونږ یې بده ځانګړي Bobby.
Excuse me, everyone. We are almost at the end of the breakout session. We have exactly 5 minutes left for the discussions. Kindly reminding our facilitators to please wrap up the discussions and get back to your original seats so we can resume and proceed to the next part of our program.
Excuse me, kindly request a breakout group for Pakistan and Nepal to wrap up the discussion. Bangladesh breakout group has been finished, the discussion, so we will resume the sections again at around 4. So, kindly request to Nepal and Pakistan to wrap up the discussion. Thank you.
think everyone's about done with the discussions. May we invite a representative from each group to give a synthesis of key learning or recommendations from their discussions. Is there anybody who would like to start the presentation of IDs? Bangladesh, yes. Ladies and gentlemen, if we may have your attention, please. Our country coordinator from Bangladesh is ready to present the findings from the breakout groups discussion on Bangladesh DSSs.
So from Bangladesh side, myself, Raihan from RIMES will be presenting, and from our group, there was our Honorable Joint Secretary from Planning Commission, Nusrat Rahman Madam was there, and we had 2 colleagues from the bank and also the senior scientific officer from WARPO. And I think we had 2 more colleagues from Maldives and Sri Lanka with us. We also got some regional insights. So what I think I will continue, but the Pakistan discussion is still continuing. Is that okay? I continue to present or? Okay. So Ruby, I think there have been couple of 2 minutes. So I will go ahead. So as we have seen yesterday, there have been many user need assessments and like requirements and gaps identified. So in our group discussion, we try to focus like what more is needed and like what additional requirements could come. So for the National Hydromet Service Providers, we have two specific recommendations and requirements to take up. One is to introduce the Upojela specific forecast. So for different sectors to provide advisories at the sub-district or sub-national level, it is required to have the Upojela specific forecast, so that we have put as one requirement. And the other one is, we have seen we are already integrating the climate projection data, but how this data can be translated into hydrological flux or other implications. So that also needs to be modeled or simulated. In terms of sector, we also did the same. So we tried to identify few additional requirements than the user need assessment. So in terms of agriculture, we have identified the agriculture extension workers, academicians, NGOs, research institutes, Med Department, Ministry of Agriculture, and other relevant ministries as the users. And we think using the DSS, the users can conduct seasonal planning, use it in disaster risk management, and also provide advisories on intercultural operations. And it will also allow them to develop some research scoping and also bring some changes in policies, especially when we talk about climate projections. In terms of what products can be added, for example, there was one specific requirement from Water Resources Planning Organization, and which we actually applied in all the 3 sectors, that includes quantifying the impact of climate change in terms of, say, for example, salinity or sea level rise, and also quantifying it in monetary terms. And there was another recommendation in all the 3 sectors, the information requirement, it shouldn't be within the boundary of their role of business. So that we have included as a recommendation. And the information can be visualized in terms of maps, tables, infographics, and in some cases also as photographs. That information came, particularly in the agriculture sector. It was discussed that Department of Agricultural Extension is planning to develop some climate cell initially at the national level, so that can be utilized for disseminating this information. And besides extension workers, the channels that can be considered, that includes email, SMS, voice messages, social media, loudspeaker at the local level, and also mobile application for disseminating the advisories. So the requirement is pretty much similar in the livestock sector, but in terms of decision making, it was said that for regular, besides regular advisories, and for extreme events, besides disaster management, the information could be used for fodder management and designing climate resilient shelters. And in case of water sector, we focused on flood forecasting and warning center, where besides quantifying the climate change impact or the hydrological flux, we discussed introducing hydrological drought monitoring, and also groundwater monitoring, which to some extent could also contribute in hydrological drought monitoring. And there was a recommendation to use gray satellite data for extensive groundwater monitoring. And there was also another requirement for erosion prediction. For erosion prediction, we already yesterday noted the recommendation that there were some research that we could expand. And the information could be disseminated through disaster management committees, through emails, SMS, voice message, social media, and of course at the local level through loudspeakers. So we basically targeted these three sectors: agriculture, livestock, and water for flood forecasting and warning center, as we had some limited participants from the sectors. So that's all from my side. Thank you.
Thank you, Rayhan. Do we have any other responses from Bangladesh? Is our Nepal or Pakistan team ready to present their findings? Oh, Pakistan. We have Mr. Shakir.
For Pakistan, we have quite a detailed discussion of all the decision support system for our stakeholder departments. But here I'll try to present that very brief. But we have quite a lot. We have a quite detailed discussion points. If any of the participants is interested to know in detail, we can sit together and discuss that in detail as well. I'll start from the decision support system for the Ministry of Planning, Development and Special Initiative, whose primary users of the system will be the Ministry of Planning and the Planning Commission. The important decision that the Minister of Planning, Development and Special Initiative will be facilitated through the decision support system will be the investment and development decisions and various other decisions at the national and provincial level. The key information discussed and requested to be provided through a DSS will be the area specific decision for planning projects for at the national or provincial level. So we can identify area at risk and should be avoided during the planning of projects. Information should be presented in the shape of reports, and that should be presented on a frequently on bi-monthly or monthly basis. For Punjab Agriculture Department, the users of the decision support system will be the Ministry of Agriculture Punjab, Ministry of Water Resources, directorates, extension workers, farmers, their research and development boards, and their research institutes in the Punjab Agriculture Department. The key short-term decisions that will be supported through a decision support system will be the plantation of seeds. The long-term decision to be supported through the DSS will be the agricultural policies and a policy that was discussed to still to be done, and that is 3 years policy for the Punjab Agriculture Department. And we are hopeful that once the decision support system is developed, will facilitate in shaping that policy. The key information requested are discussed to be shared about how we can increase the cotton production in the Punjab that was about a decade ago, so that our farmers can be motivated, can be encouraged to grow more cotton instead of other crops whose production can be attained from other provinces. And you might be aware of the fact that Pakistan was at a decade ago a major cotton production country, but unfortunately we have lost that position, and thanks to the officials of the Punjab Agriculture Department who are trying to their level best to be at their stage again. The information to be presented will be in the shape of advisories, reports, or other material that can be easily accessible or presentable at various stages, and that should be at seasonal or sub-seasonal seasonal information. For the Balochistan Agriculture Department, the users of the decision support system will be the Ministry of Agriculture, Balochistan, Ministry of Water Resources, their directorates, extension workers, and farmers, along with the academia in the Balochistan. The short-term decisions that will be facilitated through a decision support system will be the plantation of seeds. The long-term decision to be supported through the decision support system, there will be a 5-year agriculture sector plan for the Balochistan Agriculture Department. Information required on immediate basis or short-term basis or frequent basis will be the best quality short duration wheat seed or other crops that are grown in the Balochistan province. So their request is to share information about the best quality short duration seeds. The information to be presented in the form of emails and hard copies or hard reports with the higher officials or the policymakers, and in the form of mass media or brochures to the extension workers or to the farmers to be aware of the decisions or the information that we wish to share with them. The information to be shared on the seasonal or sub-seasonal basis. For the Sindh Irrigation Department, we and Ministry of Finance, unfortunately due to the shortage of time, we couldn't complete it, and we will try to complete that tomorrow, and we'll share with the participant once completed. Thank you.
Thank you, Mr. Shakil. May we hear from the Nepal team now? Present. Oh, sir.
Thank you. So I'm Rajendra Sharma from NDR Academy, Nepal. The team Nepal have made this presentation with a lot of discussion, and we have done sector-wise. For agriculture sector, the planners, decision makers would be in policy level, ministry, various ministries, academia, development partners, humanitarian agencies, research agencies, etc. And end users would be the farmers, obviously. Focusing on the paddy, we have start with various crops. We have, for example, we have done with paddy. The long-term climate sensitive plants should be developing of new varieties, and the medium term would be paddy plantation season time, change in seasonal calendar, and short term would be agronomic practices. And for the information requirements, for enhanced risk and resource management, climatic projection, crop characteristics, duration of crop, productivity, weather and climate forecasting, seasonal forecasting, for example, drought, flood would be the example, and generation of crop. So information products would be the maps, tables, infographics, etc. channel and frequency of information dissemination and feedback, mobile apps, web portal, weather news, channel news, bites in the national news agencies, local FM, radio, TV, mobile SMS, frequency based on the intensity. So hourly to daily frequency, depending upon the intensity of specific hazards. So in disaster sector, the end user would be vulnerable people and community-based disaster management committees. And in the government sector, National Emergency Operations Center. It is a national body, and Provincial Emergency Operations Center, District Emergency Operations Center, and finally local emergency operation centers. These are all emergency operation sectors in respective levels. For communication and response, NGOs working in the field, they are also very NGOs and INGOs are also working in the field level, so they also need the information. And chief district officers, police, army uses the information for response and also for communication. And in planning, long-term planning, disaster resilience framework, land use planning, establishment of evacuation centers, learning management systems, local disaster LDCRP, local disaster climate response plan, and LAPA, that is local adaptation plan for action. NAPA, that is national adaptation plan for actions. These are all long-term plans that can be done. In medium term, forecast-based preparedness, early action can be the plans, and in short term, early warning, emergency response, evacuation. This can be the short term plans. So for information requirements, information of risks is vital. Always it is vital for emergency response in disaster. So risks is a combination of exposure, vulnerability, hazard. We all know that. This all information is needed for the assessment and information. Hazard. In hazard, heavy precipitation, flood duration, rainfall duration, intensity of precipitation, slope and land cover, climate extremes. These are the information needed for hazard. And for exposure, population, age group, assets and infrastructures. And in vulnerability, we need disaggregated information of the population. So information products can be in the form of graph maps for policy level, and in the form of voice messages, sirens, etc. for end users. Channel and frequency of information dissemination and feedback. It is policy level. For policy level, website is okay, and for lower level, SMS, television, FM, siren, social media, community-based dissemination system is required. For hydromet, Department of Hydrology and Meteorology sector, all sectors. So planners, decision makers, maybe multiple cross-cutting sectors like agriculture, water resource, disaster, transport, etc. Key plans and decisions. For medium term, expansion of customized service. For short term, climate service, that is climate service demanded by sectors whenever feasible, scaling of flood, forecasting for major rivers, increasing the level of forecast, information requirements for enhanced risks and resource management, that is SPI information, heat wave, cold wave information, and in the form information can be in the form of graph, table, map, infographics, and channel and frequency of information dissemination and feedback, that is NDRRMA, district office, federal government, etc. Thank you.
Thank you very much once again to our country representatives for sharing the group's insights, and to ensure that all these valuable inputs are integrated into the DSS's development moving forward. We'll be establishing the DSS communities of practice, and to guide us through this initiative, we'll be maybe call on Ms. J. Elaine Naparat of RINES, monitoring and evaluation specialist for RINES, to present the TOR.
Good evening. I will not take much of your time. We would like to inform you that we are evolving the terms of reference for the community of practice that we are developing for the system development, further system development for RDAS and the DSS. So a community of practice, as defined, is a group of people who share a common interrelated concern and work together for enhancing as they interact regularly and share experiences. So this platform will be able to provide this community of practice will be able to provide a forum for technical and sectoral cooperation and collaboration, for providing guidance, input, and expertise to the RDAS development, for guiding, providing the direction for further of the systems. So anyway, for this terms of reference, we will be pursuing this further. We will be sharing it with you as soon as possible, and we look forward to your comments probably in 2 weeks or so time. So yes, so that will be all from my end, and back to you. Thank you.
Thank you, Ms. Jane. And to wrap up today's workshop, may we please call on again Ms. Ruby Rose Policarpio, Project Director for Care Component 1.
Yeah, thank you very much. We are almost at the end of our work for today. I think the objective of today is basically looking at initial thoughts into refining the regional data and analytics service, as well as the different decision support systems for the different sectors in different countries. From the morning, you're able to hear and see the current capacities of various tools available. And again, the value of these tools would be on how eventually it will be used in your different sectors. So moving forward, we have been, of course, noting down recommendations that you have put forward in the plenary, in the working group discussions. Of course, refinements would be required, looking into these requirements. And what is obvious as of now is that further engagements, closer engagements with you, and collaboration in order for us to do regular testing of the products and getting your feedback on refinements of the products, so that you can get better products as we move along. The idea is, again, will be an iterative process, and the more feedback we get from you, the more you define your requirements, the more that we can address such requirements. So I think in a matter of a few days, we will be reaching out to all of you for identifying priorities that we will be finalizing, or possibly during the time we have finalized already with the bank, and also looking at how we move forward for refinement of both the RDAS and the decision support systems that we have get a glimpse on for today. So we will look at also the communities of practice, how to involve all of you in different perspectives, in different expertise, different domain knowledge, together with the development teams on how these expertise experiences can be integrated so that we can evolve tools that will be most effective and most efficient for your purposes. Definitely, again, looking forward, more engagements, closer work with you, co-development processes will be pursued, and we will do that as soon as we finalize plans and the direction of care component 1 with the bank. So I think that's it for me this afternoon. Again, thank you so much for the participation. We are appreciating the comments. We are appreciating the inputs you have provided for this session. And we have just a final speaker for today. So if I may give the floor back to Nika for the final speaker for the day.
Thank you so much, Ms. Ruby, for that comprehensive summary of all that has transpired today. I'm sure everyone took notes and are going away from today's workshop with a lot to ponder on. So now, to officially close today's event, please join me in welcoming Mr. A.R. Subaya, Director of the Regional Integrated Multi-Hazard Early Warning Systems, RIMS.
Thank you very much for all of you. Really, I have come to really thank you. And that will be very short because already the time is up and the whole day you've been working. You'll be tired also. I just want to have only three messages. Message number 1 is that the proof of D2 is in the building. So we need to demonstrate at the operational level what all we are doing there. So this has no meaning unless it makes a difference in the operational use of the decision makers at the national, provincial, community levels. That is one thing. That means we need to, the project period is ending in 2025. We need to catch up now to see that the next monsoon time, we are able to demonstrate the benefits, the relevance of this, whatever that we are, DSS, various DSS, including RDAS, national DSS, everything, at the operational user level, so that you get a feedback and train it. So the time is up now. We need to really work very hard to see that next monsoon we put into operation of these services. So whatever we eat theoretically, whatever we talk about here and all, will be no meaning for the operational users at the national, provincial, and community level. That is message number 1. Message number 2 is when you are going to have this kind of a time frame, then we need to have a kind of integration of all the institutional mechanisms as one family. Suppose if the NHMS is not giving data to the agriculture is not sharing with irrigation is not sharing with say whatever the sister departments, it will not happen, anything will not happen. So we need to have institutional a kind of buy-in ownership and a demand. You give something, you get something. It's an incentive-based kind of interaction. It's not something we are going, because we are all the government. We are basically only for the communities and the for the development purposes. So keeping this one goal, please ensure that please share data among yourselves. This data is not going to be shared by any other institutions. It's only within the country. Unless you share data and get data, it will be very difficult to achieve this target of rolling out something during the monsoon time. The third and last message is that because of this framework we are working within the system, those who are already given consent letters, I thank you very profusely on the purpose. those who are not able to give the consent letter, it will be impossible for us under this framework to engage. So under this project, there will be no engagement if you are not given the consent letter by 31st October or something like that. So there is a time frame involved. Please, these are the three necessities. Kindly see that you are there. But that it doesn't mean only under the CARE project this is applying. We will continue to work with you in all other routine programs because this is an institution owned by the countries. It's not just something external to you. It is an integral part of the system itself. So we have a long-term kind of engagement with the countries. Our programs, other programs will continue, but not the CARE project, this particular component. So with these words, I thank you all. I really thank all of you for sitting very hard for last, I think, 3 days to see, 2 days or 3 days, whatever. So to ensure that it is happening there. Please be assured of that, the whole thing, that you will be making a transformative process into that, because this is mostly not a very big rocket science or something. It is 90% of institutional transformation. Unless institutions work together, nothing will happen. Only 10% is technical. So this is the kind of myth we are saying, that so much artificial intelligence, this and that and all come, they will scare you. But it is nothing, because it is only basically institutional transformation. And 10% is technical, because technical is a driver to bring that transformation. With these words, I wish you all the best. Thank you very much for giving opportunity for us to work with you, and we will keep in touch with you. Wish you all the best. Thank you very much.
Thank you very much, Mr. Subaya. And before we let everyone go for the day, may I kindly please ask everyone to gather in front for one group photo? Maybe some of us could go up on the stage and some could stand in front. Those of you on Zoom, if you're comfortable in turning on your cameras to join the group photo, please do so. Yeah, sure. I'm sorry. So that concludes today's workshop. On behalf of the organizing team, the Care for South Asia project, I would like to thank everyone again all our speakers, panelists, facilitators, and participants for joining us today. Please fill out the survey questionnaire flash on the screen. You may access it via the QR code. Your response will be invaluable in helping us improve as we plan for more cares for South Asia events in the future. Again, thank you very much, everyone, and see you all tomorrow.